Hello students. Today we are going to solve few questions on dynamics. So here few questions are on motion of trains, boats and streams. So when it comes to motion of trains, concepts involved are speed, right? Speed is a concept in dynamics, whereas distance, there are few questions on streams. So that means mainly upstream speed, downstream speed, right? So these concepts are on upstream motion and downstream motion of boats, right? Upstream speed, downstream speed, right? When there are two different speeds are given, speed of a body, right? In first case and second case, speed 1 and 2, speed 2. When two different speeds are given, we use the term relative speed. Relative speed, right? So these many concepts are involved in these questions. Totally there are 40 questions we are going to practice. Let's begin with question number 1. A train running at a speed of 20 meter per second crosses a pole in 24 seconds less than it requires to cross a platform thrice its length at the same speed. What is the length of the train? So very easy questions. So here students, we'll consider the time taken by the train to cross the platform. So we'll consider platform and a pole, right? So here length of the platform is thrice its length. So thrice its length means 3 times length of the train, right? If you consider L as length of the train, so we'll consider L as length of the train, right? So platform length will be 3 times L, right? And it requires 24 seconds less than time required to cross the platform. So if you consider T as time required to cross the platform, time required to cross the platform is T seconds, the unit is seconds, then time required to cross the pole will be T minus 24 seconds, right? So in order to cross the pole, so length crossed by the train will be its own length, which is L, right? Because length of the pole is very negligible compared to length of the train. So if you consider here L as length of the train, right, moving in this direction, this is a pole, right? So compared to the length of the train, length of the pole is very negligible. Therefore, train has to cover its own length, right? Therefore, distance traveled by the train while crossing the pole will be its own length, right? Therefore, distance traveled will be L, whereas while crossing the platform, distance traveled by the train will be length of the platform as well as its own length, right? It has to cover its own length, right? So just for example, this is a platform and here is a train, right? This is train, this is a platform, right? Length of the platform is 3L, whereas length of the train is L, right? While crossing the platform, right, train has to cover its own length also, right? Therefore, the total distance traveled by the train will be, while crossing the platform, it becomes 3L plus L, which is 4L, right? And it takes T seconds of time to cross the platform. Here the question is, what is the length of the train? Right? So here speed is given. So train is running at a speed of 20 meter per second, which is constant while crossing the platform also, while crossing the pole also. We will mention speed of the train. Speed is 20 meter per second, whereas while crossing the pole also, speed is equal to 20 meter per second, right? So here we need to find length of the train. We all know that speed is equal to distance traveled by time taken. Distance by time taken, right? Therefore, we'll consider distance traveled by the train while crossing the platform is 4L and it takes T seconds of time. Since speed is same, therefore we'll consider speed of the train as the distance traveled is 4L divided by time taken is T seconds, right? T seconds. Whereas while crossing the pole, speed is equal to distance traveled is length of the train itself while crossing the pole, which is L divided by T minus 24 is equal to speed. Since speed of the train is constant, which is 20 meter per second, so we'll consider 20 is equal to 4L by T. Here also 20 is equal to L by T minus 24, right? Here we can equate equation 1 and 2, right? Therefore, we can equate the right hand side. So, therefore, 4L by T is equal to L by T minus 24. We can cancel L and L. Therefore, we have 4 by T is equal to 1 by T minus 24. Simplify it. We have 4T minus 4 into 24 is equal to T, right? 4T. It is not 4L. Therefore, 4T minus T is 3T is equal to 4 into 24. Hence, value of T becomes, so 4 into 24 by 3. So, 3 into 8. So, it becomes 32 seconds. Here, what is asked in the question? We need to find length of the train. We need to find the value of L. Substitute the value of T in any of the equation, either 1 or 2, right? Equation 1 becomes, what is equation 1? 20 is equal to 4L by T, right? So, 20 is equal to 4L by T. 20 is equal to 4L by T is 32. Therefore, 4L is equal to 20 into 32. So, value of L becomes 20 into 32 by 4. Right? Therefore, 4 into 5 is 20. So, 160. 5 into 32 is 160. So, length of the train is 160 meters. Right? Here, the speed is in terms of meter per second. Therefore, length is in terms of meter, right? Since speed is distance by time, meter per second, right? Length is in terms of meter. 160 meter is length of the train, right? This is how we need to solve this type of question, right? Option A is the right answer. Students, if you want to practice such questions on dynamics, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 2. A train running at 72 km per hour crosses a 200-meter long platform in 22 seconds. The length of the train is. So students will consider a train of length x meter. Here we need to find length of the train. Therefore, let it be x meter, right? So the train has to cover a platform, right? It has to cross a platform of length 200 meter and time taken by train is 22 seconds. Here value of t is 22 seconds, right? And speed of the train is 72 kilometer per hour, right? Kilometer per hour. So here we need length of the train, that is value of x, right? So while crossing the platform, train has to cover its own length also, right? Therefore, distance traveled by the train will be, just while crossing the platform. So it is 200 meter length of the platform plus its own length, which is x meter, right? And time taken by the train is already given, which is 22 seconds. And speed of the train is 72 kilometer per hour, expressed in terms of meter per second, right? Since the length is in terms of meter, time is in terms of second, we'll express the speed in terms of meter per second. Here 72 kilometer is 72 into 1000 meter per hour. 1 hour is 3600 seconds, right? Therefore, we use the concept of speed to find the length of the train. So speed is equal to distance by time, right? Distance by time taken. Therefore, speed. So 72 into 1000 by 3600 is equal to distance traveled by the train is 200 plus x meters divided by 22. Simplify it, you will get the value of x, right? Here we can cancel two zeros, and 32 into 2 is 72. So 2 into 10 is 20 into 22 is equal to 200 plus x, right? So 20 into 22 is 440 minus 200 gives value of x. Therefore, x is equal to 240 meters. What is x? Length of the train. According to our assumption, so length of the train is x, which is equal to 240 meter. It crosses a platform of length 200 meter in 22 seconds. So that its speed becomes 72 kilometer per hour, right? So that's total distance covered by the train will be 240 plus 200 meter, which is 440 meters, right? So for the given question, 240 meter, option D is the right answer. Question number 3. A boat running downstream covers a distance of 30 kilometers in 2 hours. While coming back, the boat takes 6 hours to cover the same distance. If the speed of the current is half that of the boat, find speed of that boat in kilometer per hour. So before going to the solution, let us understand what is downstream motion and upstream motion. So we'll consider a stream or a current. So this is stream, or in general term, we can call it as current. And we'll consider a boat, right? So because of its motion, current has got some speed, right? Let y kilometer per hour, or it may be meter per second, y kilometer per hour be the speed of the current, right? And x kilometer per hour be the speed of the boat, right? Since boat is moving in the same direction of the current, right? This is downstream motion, right? So if boat is moving in the same direction of the current, then it is called downstream motion, right? Or the particular speed is called downstream speed. Therefore, downstream speed is always sum of the speeds of boat and current, which is x plus y. Because the reason is boat is moving in the same direction of the current, right? So here, while coming back, right, in the second case, boat is coming back. That means in the opposite direction of the current, right? So opposite direction of the current. Then such type of motion is called upstream motion, right? Upstream motion. And the particular speed is called upstream speed. Upstream speed. Since boat is moving in the opposite direction of the current, so upstream speed is speed of the boat minus speed of the current, right? According to the concept of speed, speed is always distance by time taken, distance traveled by time taken. Now come back to the question. Boat running downstream covers a distance of 30 kilometers in 2 hours, right? Therefore, we can take downstream speed x plus y as distance traveled is 30 kilometers, time taken is 2 hours, right? While coming back, the boat takes 6 hours to cover the same distance. So here, while coming back means upstream speed. While coming back means in the upstream motion, right? Upstream speed becomes x minus y is equal to distance traveled is same, which is 30 kilometer distance. Time taken is 6 hours. To cover the same distance, boat takes 6 hours of time. So speed of the current is half that of the boat. So speed of the current, according to our assumption, it is y. It is half the speed of the boat, which is x by 2, right? So if y is x by 2, x plus y becomes x plus x by 2, which is 30 by 2 is 15, right? So find the speed of boat in kilometer. So that is value of x. We need to find value of x. Very simple calculation. So go for it. So here LCM is 2, numerator becomes 2x plus x, which is 3x, is 15. Therefore, value of 3x is 15 into 2. Therefore, x is 15 into 2, 30 by 3 is 10, right? The unit is kilometer per hour, right? Therefore, here x is speed of the boat, right? Speed of boat is 10 kilometer per hour. Option B is the right answer. Even you can take the downstream speed, right? By substituting a value of y as x by 2. Here 30 by 6 is how much? 5, right? So here the left hand side becomes, yes, x by 2 is 5. Therefore, x is 5 into 2, which is 10 kilometer per hour. Right? So in any equation, you can substitute the value of y as x by 2. You will get the same answer. That is, speed of the boat is 10 kilometer per hour. Hence, option B is the right answer. Question number 4. Due to some fault, the driver of a train has to reduce the speed of a train from 200 km per hour to 180 km per hour. Due to the decrease in speed, it takes 60 minutes more than the usual time to complete its journey. What is the distance traveled by the train? So here are two conditions, students. In ideal case, two cases. In ideal case, so speed of the train is 200 km per hour, right? So let T1 be the time taken by the train to reach D distance, right? So here, time taken by the train, right, to reach the distance of D kilometer be T1 R, right? So time taken by the train to reach the distance D is T1 R, right? But in real case, right? So due to fault, that is in real case, so the speed of the train is reduced from 200 to 180 kilometer per hour, right? So in real case, the speed of the train is 180 kilometer per hour, right? And it takes 60 minutes more than the usual time. Therefore, time taken by the train will be T1 plus 60 minutes, right? In terms of hour, it is divided by 60 hour. 60 minutes means 1 hour, right? So instead of 60 by 60, directly we'll take T1 plus 1 hour, right? Therefore, here, what is the distance traveled by the train to cover the same distance, right? Here, distance is same in ideal case and also in the real case. Distance is D kilometer. We need to find the value of D, right? Very simple question. Since distance is equal to, according to the concept of speed, speed is distance by time, right? Distance is speed into time. Speed into time. So, distance D is equal to 200 into T1. Whereas in real case, distance D is equal to 180 into T1 plus 1. Right? We can equate right hand side parts since distance is same. Right? Therefore, 200 into T1 is equal to 180 into T1 plus 1. So 200 T1 minus 180 T1 is equal to 180. Hence, 20 T1 is equal to 180, right? Therefore, T1 is equal to 180 by 20 is 9. So, T1 is the time taken by train, right? Therefore, it is in terms of hour, right? In ideal case, time taken by the train to cover D distance is 9 hours, right? But in real case, due to fault, it takes 1 hour extra, that is 10 hours, right? So it becomes 10 hours. Here the question is, what is the distance covered by the train, right? Therefore, So in any of the equations, either in 1 or 2, in equation 1 or 2, you can substitute the value of t, right? Therefore, equation 1 becomes distance traveled by the train D is equal to 200 into T1. So which is 200 into 9, which is 1800 kilometers. Distance is in terms of kilometers. Therefore, 1800 kilometer is the distance traveled by the train. Hence, option B is the right answer. Question number 5. A motorboat whose speed is 15 km per hour in still water goes 30 km downstream and comes back in a total of 4 hours 30 minutes. What is the speed of the stream? So here we'll consider a stream and a boat, right? Here motorboat whose speed is 15 km per hour in still water, right? So we'll consider y kilometer per hour as a speed of the stream, right? Stream's speed as y kilometer per hour. Here motorboat goes 30 kilometer downstream. So the distance is 30 kilometer downstream and it comes back. Therefore, both the ways the distances are 30 kilometers and 30 kilometers, right? Totally it travels 60 kilometer distance, right? Therefore, total distance traveled is, so upstream motion, in upstream motion 30 kilometer, this is upstream motion, that means coming back, while coming back motorboat covers 30 kilometer distance, and in downstream motion it covers 30 kilometer distance. Totally it is 60 kilometer distance, right? And it takes total of 4 hours 30 minutes. So total time is 4.5 hours, right? 4 hours 30 minutes. What is the speed of the stream? So we have taken y kilometer per hour as a speed of the stream, right? Speed of the stream as y kilometer per hour, right? So here to solve this question, so we have to understand the concept of upstream motion and downstream motion, right? Here motorboat having the speed of 50 kilometer per hour is moving with the speed of the stream, right? In the same direction of the stream. So it has got the speed of the stream also. Along with its own speed, it has got speed of the stream also. Such type of motion is called downstream motion, right? So in the same direction of the stream, motorboat has got its speed. Therefore, such type of speed is called downstream speed, right? Therefore, downstream speed here is speed of the stream y kilometer per hour plus the speed of the boat. So we'll consider speed of the boat as x kilometer per hour, which is 15 kilometer per hour, right? The value is already given. So therefore, the downstream speed is sum of the speeds of boat and stream, right? Now it comes back, that means it covers the same distance, right? Here in downstream speed, distance D is equal to 30 kilometer. While coming back, upstream speed is, so in upstream motion, both will be moving in the opposite direction of the stream. Therefore, upstream speed is x minus y. Speed of the boat minus speed of the stream, and it covers the same distance. Distance is 30 kilometer, right? What is the question here? What is the speed of the stream? We need to find the value of y. So what is the value of y, right? So what about the time? So totally it takes 4.5 hours, right? So in each case, we have to consider time taken by the boat, both in upstream motion and downstream motion, right? We'll go one by one. Here, so let us consider downstream speed. Since we know that speed is distance by time, time becomes distance by speed, right? Therefore, so in first half of motion, that is in downstream motion, time becomes, what is time? Since speed is distance by time, time is distance by speed, right? Distance is 30 kilometer. speed is x plus y. So which is nothing but 15 plus y. Time taken by the boat in downstream motion is equal to 30 by distance by speed, 50 plus y, right? So let it be T1. Whereas time taken by the boat in the upstream motion, which is again distance by upstream speed x minus y, let it be T2. Now we will consider total time taken by the boat. Total time is equal to, which is already given, 4.5 hours, right? Total time taken by the boat in the whole journey is 4.5 hours. Therefore, it is T1 plus T2 is equal to 4.5 hours, right? So where T1 is 30 by 15 plus y plus T2 is 30 by 15 minus y is equal to 4.5 hours is nothing but 9 by 2 hours, right? We'll simplify it. Here, LCM is 15 plus y into 15 minus y, which is in the form of a plus b into a minus b, which is a square minus b square. 15 square minus y square is the LCM. And the numerator becomes 30 into 15 minus y plus 30 into 15 plus y is equal to 9 by 2. Right? On simplification, so here we'll take 30 as common and 15 minus y plus 15 plus y. Minus y and plus y will get cancelled. So we have 15 plus 15, which is 30, divided by 15 square is 225 minus y square is 9 by 2. Right? Therefore, 30 into 30 is 900 into 2 divided by 9 is equal to 225 minus y square. So 9 into 100 and 100 into 2 is 200, right? Is equal to 225 minus y square. Therefore, value of y square is 225 minus 200 is 25. Hence, y is equal to 5, right? Value of y is equal to 5. What is y according to our assumption? Y is speed of the stream, right? So we have assumed speed of the stream as y, which is equal to 5 km per hour, right? Therefore, option C is the right answer. Question number 6. A train moves past a telegraph post and a bridge 264-meter long in 8 seconds and 20 seconds respectively. Find the speed of the train. So students will consider a telegraph post like this and a bridge, right? And a bridge. So train moves past a telegraph post and a bridge. We'll consider a train, right? Here we need to find the speed of the train. So let x be speed of the train in terms of kilometer per hour, right? X kilometer per hour be speed of train, right? So when train passes the telegraph post, right, it covers its whole length, right? While passing the telegraph post or while crossing the telegraph post, distance covered by train will be its own length, right? Therefore, we'll consider distance covered, right, while crossing telegraph post is equal to, so according to the concept of speed, it is speed is distance by time. Hence, distance is equal to speed into time. Speed into time, right? So to cross the telegraph post, right, train takes 8 seconds of time and speed of the train is x kilometer per hour according to our assumption. Therefore, distance covered while crossing telegraph post is speed of the train into time taken by it, which is equal to speed is x into 8 seconds. Therefore, 8x meter is, since time is in terms of seconds, right, we'll consider 8x meter. So if you take x as kilometer per hour, right, so then you have to convert time into, time is in terms of seconds, convert the second in terms of hour, right? So we'll, for our convenience, we'll consider it as 8x meter. So at the end, we'll convert this meter into kilometer, right? So here distance covered while crossing telegraph post is 8x meter, right? So while crossing the bridge, what is the distance covered by the train, right? So distance covered while crossing the bridge, is equal to, so here in terms of speed and time, right? In terms of speed and time, speed of the train is x, whereas train takes 20 seconds of time. Therefore, it becomes a 20x meters, right? So here train covers the distance of its own length and bridge length, right? While crossing the bridge, train has to cover the length of the bridge, also its own length, right? Therefore, so 20x distance covered while crossing the bridge, right? Distance covered by train while crossing the bridge is 20x minus while crossing the telegraph post is equal to length of the bridge. The difference in the distance covered by the train is length of the bridge, right? So we'll express distance, right? We have expressed already in terms of speed and time. So 20x minus 8x is 12x and length of the bridge is already given, right? Which is 264 meter. So it is 264 and x is 264 by 12. So which is 22 meter per second. Since x is the speed of the train, is 22 meter per second. Here in the given options, the speed is in terms of kilometer per hour. So we'll convert meter per second into kilometer per hour. So it is 22 into 10 raised to minus 3 kilometer per second means divided by second. So 1 second is 1 by 3600 R, right? So in simplification, so we'll take 22. So this 3600 goes to numerator by 10 raised to minus 3 is divided by 1000, right? So we have 22 into 3.6, right? So you will get 22 into 3.6 as 79.2, right? In terms of kilometer per hour, right? Speed of the train is 79.2 kilometer per hour. So option A is the right answer. Question number 7. A train is moving with a speed of 92.4 km per hour. How many meters will it cover in 10 minutes? Here, speed of the train is given. So, 92.4 km per hour. So, very easy question. So, time taken to cover a distance is given. Time is 10 minutes, right? We need to find distance covered by it, right? What is the distance? Since speed is equal to distance by time, distance d by time t, right? Speed is given, time is given, we need to find the distance. Here time is in terms of minutes. Let us convert speed in terms of meter per minute, right? So here the train is moving, how many meters? Distance should be expressed in terms of meters, right? Therefore, let us express the speed in terms of meters per minute, right? Meters per minute. Since time is in terms of minute, so we'll convert the speed. 92.4, so kilometer means 1000 meter, right? Divided by hour. Per hour means divided by 1 hour. 1 hour is 60 minutes. It becomes divided by 60, right? Therefore, speed becomes 92.4 into 1000 by 60 is equal to distance d, right, divided by time is 10 minutes, right? Therefore, d is equal to, so we can cancel 1 0 and 0. 92.4 into 100 becomes 9240, right? Into, take this 10 to the next part, which is LHS part, divided by 6. So very simple calculation. 6 into 1, 6 into 5 is 30. 6 into 4 is 24. Yes, it is 1540 into 10 is 15,400. Right? Distance is in terms of meters. Therefore, train covers 15,400 meters in 10 minutes, right? With the speed of 92.4 kilometer per hour. Therefore, option C is the right answer. Question number 8. A sailor goes 12 kilometer downstream in 48 minutes and returns in 1 hour 20 minutes. The speed of the sailor in still water is. Very easy question. Only thing is you should know the concept of upstream motion and downstream motion, right? Sailor goes 12 kilometer downstream here. So distance in downstream motion is 12 kilometer, right? And the sailor takes 48 minutes. So to go the downstream motion, he takes 48 minutes. Right? Here we are using the concept of downstream speed and upstream speed, right? So downstream speed is nothing but speed of the stream along with the speed of the boat. Here, speed of the sailor should be considered, right? So we'll consider a sailor has got some speed, right, in still water. Along with the speed of the sailor, we have to consider speed of the stream also. We'll consider speed of the sailor as x kilometer per hour, or x, here the distance is in terms of kilometer, x kilometer per minute. Per minute. Right? Since the options are in terms of hour, it is better to take x kilometer per hour as speed of the sailor and speed of the stream as y kilometer per hour. Right? Therefore, downstream speed becomes x plus y, speed of the sailor plus speed of the stream. Since the sailor is in the same direction of the stream, right? Whereas, while coming back, sailor covers the same distance, which is 12 kilometer, right? But he takes 1 hour 20 minutes of time. 1 hour 20 minutes of time to cover the same distance, right? So here we need speed of the sailor. So what is the value of x, right? So for that we'll consider upstream speed also. Upstream speed, in case of upstream motion, sailor will be moving in the opposite direction of the stream, right? Therefore, it is x minus y. So speed of the sailor minus speed of the stream gives upstream speed. Keeping this in our mind, we have to solve this problem, right? According to the concept, speed is distance by time. So distance d by time, right? So here we need value of x, right? So downstream speed is, so what is the total distance covered in downstream motion, which is 12 kilometer, and time taken is 48 minutes. So in terms of hour, it is 48 minutes divided by 60 hour, whereas distance is 12 kilometer, which is downstream speed, which is equal to x plus y. Whereas upstream speed is, here the distance covered is same, 12 kilometer, divided by time taken is 1 hour 20 minutes, right? So which is nothing but one integer 1 by 3 hour, am I right? 1 hour 20 minutes, right? So which is nothing but 60 plus 20, 80 minutes divided by 60. So which is 60 into 1, then 20 by 60. Yes, one integer 1 by 3. 1 by 3 r is the time taken in the upstream motion. Therefore, upstream speed becomes 12 divided by 1 integer 1 by 3, which is equal to x minus y. So consider these two as equation 1 and 2. Here we need the value of x, right? Therefore, we'll add equation 1 and 2 so that you can remove y, right? So now consider both RHS parts, x plus y plus x minus y, right? So x plus y plus x minus y is equal to 12 divided by 48 by 60 becomes into 60 in the numerator part, plus x minus y becomes 12 divided by 1 integer 1 by 3 becomes 4 by 3, right? So this 3 goes to denominator. Denominator of the denominator will go to numerator. So we have 2x here. 2x is equal to, so 12 into 4, 12 into 5 and 4 into 3. So we have 15 plus 4 into 3 is 12, right? So 3 into 3, which is 9. So 15 plus 9 is 24. Therefore, value of x is equal to 24 by 2, which is 12. What is x? Speed of the sailor, right? According to our assumption, it is speed of the sailor, x kilometer. Therefore, so what is the answer? 12 kilometer per hour is speed of the sailor, right? Look at the options. Option A is the right answer, 12 kilometer per hour. Question number 9. I start rowing at 11 a.m. and reach my destination by 1 p.m. rowing against the stream. On coming back, if I start at 2 p.m., I reach the starting point by 3 p.m. What is the ratio of the speed of the boat to that of the stream? So students, we'll consider a stream. Here, I start rowing against the stream means my starting point will be here, right? So here is the upstream motion, right? So this is called upstream motion. So against to the direction of the stream, motion against to the direction of the stream is called upstream motion, right? So I start rowing at 11 a.m. and reach my destination by 1 p.m. Therefore, in upstream motion, time taken by me is 11 a.m. to 1 p.m. Time is 2 hours. Right, I took 2 hours of time to reach my destination, right? And distance covered by me, it is not given in the question. For our convenience, I'll take it as d kilometer, like d kilometer with the distance covered by me, right? On coming back, so I cover the same distance, so distance here is d kilometer on coming back, right? So but I start rowing at 2 p.m. My starting point will be here, right? I start at 2 p.m. I reach the starting point. That means here, my original starting point by 3 p.m. 2 p.m. to 3 p.m. duration is 1 hour. So time taken by me while coming back is 1 hour, right? Here we need the ratio of the speed of the boat to that of the stream, right? So speed of the boat, when I start rowing, so I'll consider x as the speed of the boat. In upstream motion, right? Upstream speed is nothing but in upstream motion. So speed of the boat, x, if I take x as the speed of the boat, so we'll mention it. Speed of the boat. Since I am moving in the opposite direction of the stream in upstream motion, right? Upstream speed becomes x minus speed of the stream, right? So here y is speed of the stream. Speed of the stream. Therefore, x minus y gives upstream speed, whereas in downstream motion, x plus y gives downstream speed. X plus y gives downstream speed. Right? Using these two concepts, we are going to solve the speed of the boat to that of the stream ratio. Right? X is to y. Right? We have to find x is to y ratio. Right? For that, we'll consider upstream speed and downstream speed. Right? Let us go one by one. Downstream speed is equal to, according to the concept of speed, it is distance by time, right? So downstream speed is distance covered in 1 hour duration, right? D by 1. Since downstream speed is x plus y is d by 1, right? Whereas upstream speed is, again, by the concept, it is distance by time, distance d, time taken in the upstream motion is 2 hours. Right? Therefore, upstream speed x minus y, speed of the boat minus speed of the stream is d by 2. Right? Here we need the value of x and y first. For that, we'll consider these two as equation 1 and 2. So 1 plus 2 gives. So if you add these two equations, you can delete y, right? So that you can express x in terms of the distances. So 1 plus 2 gives 2x is equal to d plus d by 2 is 3d by 2. Therefore, x is 3d by 4, right? So, which is the speed of boat? X is speed of boat. We need speed of the stream. So, substitute the value of x in any of the equations, in equation 1 or 2, right? Therefore, equation 1 becomes x plus y is d, right? Therefore, x is 3d by 4 plus y is d. Therefore, value of y is d minus 3d by 4 is d by 4, 1 by 4d. Right? Y is d by 4, x is 3d by 4. Right? Therefore, x is to y or x by y is 3d by 4 divided by d by 4. D by 4 and d by 4 will get cancelled. We have 3 by 1 or 3 is to 1 as ratio of speed of the boat to speed of the stream. X is to y is 3 is to 1, right? Hence, option B is the right answer. Question number 10. Station X and Y are 560 kilometers apart. A train starts from X at 9 a.m. towards Y at 80 km per hour. Another train starts from Y at 120 km per hour speed at 11 a.m. When will they meet each other? So here we'll consider two stations X and Y which are 560 kilometers apart. So distance between two stations is 560 kilometers. And one train starts from X at 9 a.m. towards Y with the speed of 80 km per hour. With this speed, it moves towards another station. And another train from station Y starts with the speed of 120 km per hour. Right? We'll mention 120 km here. It starts at 11 a.m. Right? When will they meet each other? So at what time both the trains meet each other? So here, second train starts at 11 a.m. Right? At that time, so say for example, somewhere here at 11 a.m., first train will be, it has been traveled some distance at 11 a.m. Right? So what is the distance traveled by first train? D1 we should find. Right? So here, distance traveled by first train between 9 a.m. to 11 a.m. That means in 2 hours duration. Here time T1 is 2 hours duration. So what is the distance traveled by first train? We are using the concept of speed, which is distance by time here. Therefore, distance is speed into time. Speed of the first train is given 80 km per hour. Into time duration is 2 hours. So, in 2 hours, first train has traveled 120 kilometers of distance. Here, D1 is, 160 kilometers of distance. D1 is 160 kilometer. Right? So, out of 560 kilometer, so first train has traveled 160 kilometer in 2 hours duration. What is the remaining distance? D2 is 560 minus 160. 560 minus 160, which is 400 kilometer. Right? So, the first train has arrived at this position at 11 a.m. and the distance between first train and second train exactly at 11 a.m. is 400 kilometer. Right? So, at 11 a.m., distance between two trains. So, distance between two trains is equal to 400 kilometers. Right? So exactly at that point, at that time, both the trains started their journey in opposite direction. Right? So two trains are in opposite direction, moving in opposite direction. Right? Two trains moving in opposite direction with two different speeds. Two different speeds. Here we are using the concept of relative speed. So relative speed is applicable when two bodies are moving in two different speeds in opposite direction. So which is sum of the speeds, right? Sum of the speeds of two bodies. Here speed of first train is how much? 80 kilometer per hour plus speed of second train is 120 kilometer per hour, right? So sum of the speeds is considered as a relative speed of two bodies moving in different directions, opposite direction with two different speeds. According to the concept of speed, distance by time is speed. So distance between two bodies is 400 kilometer divided by time. Distance by time is equal to sum of the speed is 200. Therefore, time t is equal to 400 by 200 is equal to 2 hours. Right? So time taken by both the trains to meet each other is 200. Right? 2 hours to meet each other. To meet each other. Not to meet the destination. To meet each other is relative. It is based on relative speed. Speed of one body with respect to another. Right? So if they take 2 hours of time to meet each other, at what time they will meet? Both the trains meet. So 11 a.m. to, that means 2 hours duration is 1 p.m. Right? Therefore, 11 a.m. plus 2 hours is equal to 1 p.m. So this time they meet each other. Both the trains meet each other. Right? Therefore, 1 p.m. is the answer. Right? Look at the options. Option B is the right answer. Question number 11. Two trains are moving at 50 km per hour and 70 km per hour in an opposite direction. Their lengths are 150 meter and 100 meter respectively. The time they will take to pass each other completely is. So students, here two bodies are moving in opposite direction with two different speeds, right? So here we'll consider train 1 and train 2, right? So train 1 is moving with the speed of 50 km per hour and second train is moving with the speed of 70 km per hour in opposite direction, right? So when two bodies are moving with two different speeds in opposite direction, we use the concept of relative speed, right? So whether it is opposite direction or whether they are moving in the same direction. So we use the concept of relative speed, right? So relative speed is nothing but the speed of one body with respect to another, right? So here two trains are moving in opposite direction. So sum of their speeds, right? Sum of their speed is their relative speed. Sum of their speed. Why do we need relative speed here? So relative speed gives the point of contact of both the trains, right? That means if both the trains meet at some point or if they pass each other at some point, right? What is the distance traveled by each train? Not the total distance traveled by both the trains, distance traveled by each train divided by time taken, right? So here students, when two bodies are moving with two different speeds, right, because of relative speed, they appear to be traveling with the same speed, right? So that speed is called their relative speed, right? Here sum of their speed is equal to 50 plus 70 kilometer per hour, right? Which is 120 kilometer per hour. For us, for outsiders, so we feel that both the trains are moving with 120 kilometer per hour speed, right? Since both are moving in opposite direction. When two trains are moving the same direction, then we have to take difference in their speed. So 70 minus 50, which is 20 kilometer hour. For outsiders, we feel that two trains are moving with 20 kilometer per hour speed, right? Since here in this case, two trains are moving in opposite direction, so we feel that both the trains are moving with 120 kilometer per hour speed, right? According to the concept of speed, which is distance by time. Distance by time. Here we can equate sum of their speed to distance covered by each train. Distance covered by each divided by time taken. Time taken by each. Not the total time taken by both the trains. It is time taken by each train is equal to, so distance by time gives relative speed, right? So what is the distance covered by each train? Here, first train, so if you consider this as first train, right, has to cover its own length, right? Along with that, it has to cover length of the second train. While crossing each other, both the trains have to cover their own length as well as the other train's length. Therefore, the total distance covered by each train is 150 plus 100 meters, 100 meters by time taken by each. Here we need time taken to pass each other by each train, right? So, which is equal to 120 kilometer per hour. Since the length is or the distance covered is in terms of meter, we'll express relative speed in terms of meter per second, right? 120 into kilometer is 1 kilometer is 1000 meter per hour. 1 hour is 1 by 3600 seconds, which is equal to 250 meter by time. Let it be t, right? So we'll simplify it. So 120 into 1000. So this 3600 goes to numerator, 3600, right? 3600. So, sorry, 1 hour is 3600 seconds. So this will be divided by 3600, right? So we have to cancel two zeros and 36. So 2 into 5, 2 into 18, right? So we have 250 by t as 120 into 5 by 18. So t is equal to 250 into 18 by 120 into 5, right? So 2 into 9, 2 into 60, right? So 25 into 9 is 225 by 6 into 5 is 30. Right, again 5 into 6 and 5 into 4, 5 into 5, 45 by 6. So which is nothing but 7 integer, 6 into 7 is 42, 3 is the remainder, 7 integer 3 by 6 or 7.5, right? So t is equal to 7.5 seconds. Time is in terms of seconds. Therefore, so time taken by each train to pass each other is 7.5 seconds, right? So option D is the right answer. Students, if you want to practice such questions on trains, boards and streams, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 12. A train passes the platform 60 meters long in 20 seconds and a man standing on the platform in 16 seconds. The speed of the train is. So here speed remains the same, right? Speed is equal to, it remains the same whether it passes the platform or whether it passes the man standing or it may be a pole, whatever. So speed remains the same. So in first case, it passes a platform. We'll consider a platform of length 60 meter. This is platform. And we'll consider a train, right? So let L be the length of the train, right? And it passes the platform in 20 seconds. And we'll consider a man standing here. And it passes or it crosses that man standing here in 16 seconds, right? So here, while passing the platform, while crossing the platform, the train has to cross the platform along with its own length, right? While crossing the platform. Therefore, distance covered by train will be length of the platform, which is 60 meter, plus its own length. Let L be the length of the train, right? So distance covered will be 60 plus L meters. Whereas time taken by the train is 20 seconds. Therefore, speed of the train in this case becomes 60 plus L divided by 20. This becomes speed of the train in first case. When it crosses the man, right? Distance covered by the train will be. Distance covered by the train will be. So here, distance while crossing the man, right? So here, length of the man or portion of the man is very, very, very negligible when compared to length of the train. Therefore, when crossing the man, this man, length of the train itself is considered as the distance covered by the train, right? While crossing the man, train has to cover its own length also, right? Therefore, distance covered will be L because length of the man is negligible. Man is negligible, right? Therefore, distance will be length of the train itself, right? And train takes 16 seconds of time. Therefore, its speed becomes length, that is distance, divided by 16 seconds. So here, throughout its journey, the speed remains the same. Therefore, we can equate right-hand side parts. Therefore, 60 L, 60 plus L divided by 20 is equal to L by 16. Simplify it, you will get length of the train, right? Finally, we are going to find the speed of the train, right? We'll go to that part later. So on simplification, so 16 into 60 plus L is equal to 20L. 960 plus 16L is equal to 20L. So 960 is equal to, so 20L minus 16L is 4L. Therefore, value of L is equal to 960 by 4. So 4 into 2, 4 into 4 and 0. So length of the train, so 240 meters is length of the train. Length of the train. Here we need speed of the train. Substitute in any of the equation, either in first or second. Speed of the train is L by 16, right? Therefore, speed is equal to L by 16. L is 240 meters by 16 second. So 16 into 1, 16 into 5, right? Therefore, it is 15 meter per second is the speed of the train. Here, in the given option, speeds are in terms of kilometer per hour. We'll convert that. So 15 meter. So 1 meter is 10 raised to minus 3 kilometer. Divided by 1 second is 1 by 3600, right? 1 by 3600 hours, right? So we'll simplify it. So 15 by 1000 into 3600. So you can cancel two zeros here. So 5 into 3, 5 into 2 and 2 into 18. So we get 18 into 3, which is 54 kilometer per hour as speed of the train. 54 kilometer per hour is the answer. Therefore, option D is the right answer. Question number 13. A train left from a station sharp at midnight. 3 hours later, another train left from the same station in the same direction of the train. The other train crosses the first train at 8 a.m. Find the average speed of the two trains over the journey if the sum of their average speeds is 130 km per hour. So students will consider a station from which a train left sharp at midnight. That means at 12 a.m. train A left the station and 3 hours later. So 3 hours later means at, so 1, 2, 3. So 3 a.m. 3 hours later, another train left from the same station. So let the two trains be A and B. A and B, right? In the same direction, right? So the other train crosses the first train at 8 a.m. So here train B crosses the first train A at 8 a.m. At 8 a.m. Right? So here we need to find average speed of the two trains over the journey if the sum of their average speeds is 130 kilometer. So first we need to find their individual speeds, right? So let the speed of a first train be SA, right? So we'll consider it as SA. So which is equal to X kilometer per hour. And speed of second train, so SB is equal to Y kilometer per hour, right? So first we need to find the value of x and y, right? So based on the time taken by first train and second train, right? First train and second train, because speed depends on time. Speed is equal to distance by time. We know the formula, right? So speed is distance by time. So it is inversely proportional to time. So if the speed is more, time taken is less, or if speed is less, time taken is more. So speed is inversely proportional to time, right? So keeping this in our mind, here we'll consider time taken by train A to reach the point P where both the trains meet, right? So we'll consider point P where second train crosses the first train, right? So here time taken by A to reach point P is 12 a.m. to 8 a.m., which is 8 hours. Whereas time taken by B, so let it be TB, whereas in the first case, let it be TA. So time taken by second train to reach the point P is 3 a.m. to 8 a.m., which is 5 hours. 5 hours is time taken by second train, right? Since both the trains are moving in the same direction, right, with two different speeds, we use the concept of relative speed, right? So before going to relative speed, we'll consider time taken by both the trains, right? So TA is to TB ratio is 8 is to 5. 8 is to 5 is the ratio, right? Since time is inversely proportional to speed, or speed is inversely proportional to time, right? Therefore, so their speeds are in the ratio SA is to SB. Speeds are in the ratio 5 is to 8. Since both the trains are covering same distance, so we'll consider distance covered by train A and B as D, right? Because both the trains are meeting at point P. From the station to point P, both of them are covering same distance, right? Therefore distance is D. Will express the speed in terms of distance and time. So distance by 8, whereas SB is the same distance by 8, sorry, same distance by 5, right? Second train takes 5 hours, right? Therefore SA to SB ratio is SA to SB, so D by 8 by D by 5, so which is D by 5, which is 5 is to 8, right? So their speeds are in the ratio 5 is to 8, and the sum of their speeds is given 130 kilometer, right? Therefore sum of their speeds is 130 kilometer, 130 kilometer per hour, and the speeds are in the ratio 5 is to 8. Therefore speed of first train is 50 kilometer per hour, that of second train is 80 kilometer per hour, so that the sum becomes 80 plus 50, 130 kilometer per hour, right? Therefore, so we'll consider SA as SA plus SB is equal to 130. Since the ratio is 5 is to 8, we'll consider SA as 5x, SB as 8x, which is 130. So value of x becomes 130 by 13, which is 10, right? Therefore, SA becomes 5x, which is 5 into 10, which is 50 kilometer per hour. SB is 8x, which is 8 into 10, which is 80 kilometer per hour. What is the question asked here? So here we need to find average speed of two trains over the journey. So average speed, the formula says average speed. Average speed is equal to, the formula says here we have considered x and y as the speeds of two different trains. So average speed is, it is 2 times the product of the speeds of two trains divided by sum of the speeds of two trains. Or you can consider it as 2 times SA into SB divided by SA plus SB. Simplify it. 2 times SA is 50 into SB is 80 divided by 50 plus 80. So which is 100 into 80 by 130. Right? So simplify it. 0 and 0 will get cancelled. So we have 800 by 13, right? So 13 into 6, 78, 2 is the remainder. Then 13 into 1, so 7 is the remainder. 13 into 5, 65. Yes, 61.53 in terms of kilometer per hour is their average speed. Is it kilometer per hour? Yes. 61.53 something. So when it is rounded off to two decimals, so it is 61.54 approximately, right? So option C is the right answer. Question number 14. A train passes a platform 90-meter long in 30 seconds and a man standing on the platform in 15 seconds. The speed of the train is. So here students will consider a platform, right, of length 90-meter. And a man standing on the platform. We'll consider man standing on the platform here, right? We'll consider a train of length. This is train of length L meters, right? So it passes the platform in 30 seconds, right? Train passes the platform in 30 seconds and it passes the man in 15 seconds. 15 seconds. So we need speed of the train, right? So speed of the train, let it be S meter per second, right? S meter per second. So here, when the train crosses the platform, it has to cross the whole platform of length 90 meter, right? And also its own length, right? Therefore, so when it crosses the platform, distance traveled by train is equal to, so length of the platform 90 meter, we'll consider length of the platform plus length of the train. Length of the train. So this the distance is when the train is passing the whole platform, right? So when passing the platform, right? So the total distance traveled by the train will be 90 meter plus L meter. Whereas to cover this distance, train takes 30 seconds of time. It is already given. Time is equal to 30 seconds. Therefore, speed of the train is, by the formula, it is distance by time. Therefore, it is 90 meter plus L meter by 30 seconds. 90 plus L by 30 is speed of the train. Whereas when it when it crosses the man, right? Here, the distance while crossing the man, right? This man distance, the length, the small length is negligible when compared to length of the train, right? Therefore, when it passes through man, when passing man who is standing on the platform, the distance traveled by the train is its own length, right? So distance traveled by the train is its own length, right? Here, compared to the length of the train, so length of the man is very, very, very negligible. Therefore, we'll consider the length of the train. It has to cover its own length, right? While crossing the man. Therefore, so length of the train is considered as distance, right? And time taken to cover the distance is 15 seconds. Therefore, speed of the train is, so distance by time, L by 15, right? So we'll consider this as equation 1, equation 2. In both the cases, speed is same, right? Speed remains same. Therefore, 1 is equal to 2. Therefore, we'll equate the right-hand side parts. So 90 plus L by 30 is equal to L by 15. Simplify it. So 90 into 15. So which is 1350 plus 15L is equal to 30L. Therefore, 30L minus 15L is 15L is equal to 1350. So L is equal to, so 15 into 9 is 135. So L is equal to 90 meter. So which is length of the train. Length of the train. So what is the question here? Come back to the question. Speed of the train is. Substitute the value of L in equation 2, right? So speed of the train becomes length is 90, right? Am I right? 90 meter divided by 15 seconds, right? So speed of the train is 6 meter per second. Here in the options, the speeds are in terms of kilometer per hour. So we'll convert this. 6 meter per second is equal to, here 1 meter is 1000, sorry, 1 kilometer is 1000 meter. 1 meter is 10 raised to minus 3 kilometer. Per 1 second is 1 by 3600 hours in terms of kilometer per hour. So it becomes 6 into 3600 by 1000. So you can cancel two zeros. So here 2 into 5, 2 into 3. So we'll have 36 into 3 is 108 by 5. Right? So speed is 108 by 5. 8 by 5 kilometer per hour. Still you can simplify. So come back to the options. So here in terms of decimals we have to convert 5 into 2, 5 into 1. So 3 is the remainder. So 5 into 6. So 21.6 kilometer per hour is speed of the train. Right? 21.6. Option A is the right answer. Question number 15. The boat goes 40 kilometer upstream in 8 hours and 36 kilometer downstream in 6 hours. Find the speed of the boat in still water. So very simple question. We'll consider a stream and a boat. Right? So here boat goes 40 kilometer upstream. Upstream means in the opposite direction of the stream. So if it is stream, right, in the opposite direction of the stream, boat goes 40 kilometer distance. Distance is 40 kilometer and the time taken to cover that distance is 8 hours. Whereas it goes 36 kilometer downstream. Downstream means this direction, in the same direction of the stream, right? This is downstream motion, right? So the distance is 36 kilometer and the time taken to cover that distance is 6 hours. So we need the speed of the boat in still water, right? So we'll consider x kilometer per hour as speed of the boat and y kilometer per hour as speed of the stream. Right? So in case of downstream motion and upstream motion, we use two terms, downstream speed and upstream speed. Right? Here, downstream speed is nothing but when the boat is moving in the same direction of the speed, right? Sum of the speeds of boat and stream is considered as downstream speed. X plus y is downstream speed. Here we need speed of the boat in still water. That is value of x, right? Here we'll mention x as speed of the boat and y is speed of the stream, right? So in downstream speed is equal to x plus y, speed of the boat plus speed of the stream, right? So we'll consider this downstream speed. Here in downstream speed, distance covered is 36 kilometer. According to the concept of speed is distance by time, right? 36 kilometer in 6 hours. Time is 6 hours, right? Distance by time is equal to downstream speed, which is x plus y. Here we need value of x. Consider this as equation 1. Otherwise, you can still simplify. X plus y is equal to 6 into 6 is 36. So which is 6. Consider this as equation 1. We'll consider upstream speed. So motion in the opposite direction of the stream is upstream motion, right? This is upstream motion in which the distance traveled by the boat is 40 kilometer and the time taken is 8 hours. So we'll consider upstream speed. It is the difference between the speeds of boat and the stream. Since stream is in the opposite direction of the boat, we are subtracting speed of the stream here. Therefore, it is x minus y. According to the concept, speed is distance by time. 40 kilometer by 8 hours is x minus y. Therefore, x minus y is equal to 8 into 5 is 40. Consider this as equation 2. So here we need speed of the boat, which is the value of x. Speed of the boat in still water, right? Value of x. For that, we'll add equation 1 and 2, right? So 1 plus 2 gives 2x. Y and minus y will get cancelled. So 2x. 2x is equal to 6 plus 5, right? Here RHS are 6 and 5, 6 plus 5. So value of x is 11 by 2. So speed of boat in still water. So 2 into 5 is 10. So which is 5.5 kilometer per hour, right? X is speed of boat, right? Speed of boat in still water. Hence, 5.5 kilometer per hour is the answer, or 5.5 kilometer per hour. Option A is the right answer. Question number 16. A motorboat goes downstream 45 km per hour speed and comes back with the speed of 15 km per hour. Determine the speed of the current. So we'll consider a stream or the current, right? So here a motorboat goes in the same direction of the current, which is downstream motion, right? And the corresponding speed is called downstream speed, right? Here we'll consider two speeds, the speed of the boat as x kilometer per hour and speed of the current, right? And while coming back, right, we use the term upstream speed. Upstream speed of the boat is speed of the boat in still water, which is x minus speed of the current, which we have discussed in the previous question, right? Therefore, we'll consider x as speed of motorboat, and y as speed of the current, right? Here we need speed of the current, that is value of y, right? And downstream speed and upstream speeds are given, right? Therefore, downstream speed, which is equal to 45 kilometer per hour, which is already given in the question. So according to the concept of downstream speed, it is sum of the speed of the boat plus the current, speed of the current. X plus y is equal to 45. Consider this as equation 1, whereas upstream speed is directly given, upstream speed. So here in case of upstream motion, both will be moving in the opposite direction of the current, right? Therefore, it is x minus y, right? So here negative sign of the speed of the current indicates current is in opposite direction of the boat, right? Therefore, upstream speed is directly given here as 15 kilometer per hour. Therefore, x minus y is 15. Consider this as equation 2. Here we need speed of the current, right? That is value of y. For that, we'll consider equation 1 minus equation 2 so that you can delete x and x, right? So it becomes x minus x. So plus y minus of minus y, right, is equal to 45 minus 15. So we have 2y is equal to, it is 30. Therefore, value of y is equal to 30 by 2 is 15. So y is the speed of the current, right? According to our assumption, it is speed of the current. Y is equal to how much? 15 kilometer per hour. 15 kilometer per hour. Hence, option D is the right answer. Question number 17. Archit can swim at a rate of 6 km per hour in still water. Find the time taken by him to swim to a place 10 km downstream and back to the starting point if the rate of current is 1.5 km per hour. So as in the previous question, here also we are using the concept of upstream speed and downstream speed, right? Here Archit can swim at the rate of 6 km per hour. So we'll consider x as speed of Archit, right? So instead of speed of the boat, in this question we are considering a person, right, who is Archit. So x is the speed of Archit, which is given as 6 km per hour, right? Here value of x is given, right? A person's speed is given, so 6 km per hour in still water. So time taken by him to swim to a place 10 km downstream. Here distance in downstream motion is 10 km. Time taken by him to swim 10 km downstream and back to the starting point. Here he comes back to the starting point, so that again he covers 10 kilometers of distance in upstream motion, right? So if the rate of current is 1.5 km per hour, so if you consider y as rate of current or particularly speed of the current, right? It is nothing but speed of the stream. So y is equal to 1.5 kilometer per hour, right? In downstream motion, this is downstream motion. In downstream motion, he covers 10 kilometers distance, and also in upstream motion, right? He covers the same distance. Here we need time taken by him in the total journey, right? We need to consider total time taken by him. Total time taken by him is equal to, we need to find the total time, which is time covered or time taken by him in first part of the journey, let it be t1, right? Time taken in the downstream motion, what is t1, and also time taken by him in the upstream motion, which is t2. So sum of t1 and t2 gives total time taken by him, that we need to find, right? According to the concept of speed, so speed is distance by time. We all know that, right? Speed is distance by time. But here upstream speed and downstream speed, right? Should know that upstream speed is difference between the speeds. So speed of that person minus speed of the current, right? So we use that concept to find the total time, right? So first we'll take downstream speed. Downstream speed is equal to, so speed of the person x, right? According to the concept, it is sum of speed of the person and speed of the current, right? So in downstream motion, he covers 10 kilometer distance. According to the concept of speed, it is distance by time, right? So it is 10 kilometer by time taken by him, right? 10 by t1 is equal to x plus y, right? Here downstream speed is directly given 6 kilometer per hour, and speed of, here x is speed of Archit, right? Speed of Archit, and y is speed of the current, right? Sum of the speeds is 6 plus 1.5. Therefore, T1 is equal to 10 divided by 7.5. So here 2.5 into 3 is 7.5, 2.5 into 4. So T1 is 4 by 3 hours, right? So it takes 4 by 3 hours of time to cover 10 kilometer distance downstream, right? Whereas we'll consider upstream motion, right? So upstream speed is equal to, so according to the concept, it is x minus y, right? So speed of Archit minus speed of the current. But speed is distance by time. It is 10 by t2. 10 by t2 is equal to, here x is 6 km per hour minus 1.5. Therefore, t2 is equal to 10 divided by 4.5 or 100 by 45, right? Both are same. So 5 into 9, 5 into 20. So 20 by 9 is T2. 20 by 9 are. T1 is 4 by 3, T2 is 20 by 9. Here, come back to the question, total time taken by him. We need total time, which is T1 plus T2. We'll consider that 4 by 3 plus 20 by 9. Since 9 is the LCM, 4 into 3, 12 plus 20 is 32 by 9, right? So we'll get 9 into 3 is 27. 9 into 5, 5, 5. So it is approximately equal to 3.56, right? Here I am doing the calculation. 3.56 hours is the total time taken, right? Option B is the right answer, right? First, we need to find the individual times T1 and T2 based on the concept of upstream speed and downstream speed, right? So then add these two times, right? T1 and T2, you will get the answer. Option B is the right answer. Question number 18. Two trains 132 meter and 108 meter in length respectively are running in opposite directions. One at the rate of 32 kilometer per hour and other at the rate of 40 kilometer per hour. In what time will they be completely clear of each other from the moment they meet? So we'll consider two trains like this, which are just about to cross each other, right? Two trains are about to cross each other here, right? So we'll consider their lengths 132 meter and 108 meters. And one train is running at the speed of 32 kilometer per hour and another is moving with the speed of 40 kilometer per hour, right? Here, two bodies in general terms, when two bodies having different speeds moving in opposite direction, right? So in opposite direction, right? Here are two bodies which have different speeds and moving in opposite direction, right? In such a case, here we use the concept of relative speed of one body with respect to another body. Based on this value, relative speed of two bodies, the answer depends. So in what time they will meet, that means they will completely clear of each other. That means first train passes the second train completely and also second train passes the first train completely, right? Just imagine first train is passing the second train, right? While passing the second train, it has to cover whole 108-meter distance. Along with that, it has to cover its own length, which is 132 meter, right? So also, if the second train is passing the first train, just example. So while passing the first train, it has to cover 132 meter of distance and also it has to cover its own length, which is 108 meter, right? Therefore, therefore, here the total distance, right? So total distance crossed, right? So while clearing each other, while passing each other, right? So the moment when they meet while crossing each other, right? We'll mention at that moment while crossing each other, the total distance is equal to, so length of the first train 132 meter plus length of the second train which is 108. So together it is 240 meters. It is the total distance. When two bodies are moving in opposite directions, the relative speed, so speed of one body with respect to another is sum of their speeds, right? So speed of first train is 32 plus second train is 40, which is 72 kilometer per hour, right? In opposite direction, relative speed is sum of their speed, right? If two bodies are moving in the same direction, so difference in their speed or difference between their speed is called relative speed, right? So here we need time taken by them to clear each other, right? Just to pass each other completely, right? Therefore, according to the concept of speed, it is distance by time. Therefore, time taken to cross each other, is equal to distance by speed, right? It is total distance by relative speed, right? By relative speed. Here the total distance is 240 meters, right? And the relative speed is 72 kilometer per hour, right? 72 kilometer per hour. Since in the options, the time is in terms of seconds, we'll express the speed in terms of meter per second. 72 kilometer is 72 into 1000 meter per second is divided by 1 second, right? So it is equal to 1 by 3000, sorry, 1 hour per hour, 72 kilometer per hour. 1 hour is 3600 seconds. So in terms of meter per second, we have therefore 240 into 3600 by 72 into 1000. Right? Simplify it. So your two zeros will get cancelled. 32 into 2 is 72 and 10 into 24 is 240 and 24 by 2 is 12. So what is 12 here? 12 is time taken to cross each other, right? Time taken by the two bodies, two trains to cross each other is 12 seconds, right? Therefore, option B is the right answer. From the moment they meet, when they are about to cross each other, from this moment, right, both the trains take 12 seconds of time to cross each other completely, right, to pass each other completely. Therefore, option B is the right answer. Question number 19. A boat takes 90 minutes less to travel 36 miles downstream than to travel the same distance upstream. If the speed of the boat in still water is x miles per hour, find the speed of the stream. So we'll consider a stream, right, whose speed is y kilometer. Sorry, here the distance is in terms of miles. So y miles per hour, right? So speed of the stream, right, we'll consider speed of the stream as y miles per hour, right? Whereas speed of the boat as x miles per hour, right? Here speed of the boat is it given here? So it is the speed of the boat in still water is 10 miles per hour, right? Value of x is 10 miles per hour. As in the previous example, here also we are using the concept of upstream speed and downstream speed, right? Boat takes 9 minutes less time to travel downstream when compared to the upstream speed, right? Here, let T1 be the time taken to travel downstream. Downstream means in the same direction of the stream, in this direction. So T1 is time taken to travel downstream and T2 is time taken to travel upstream, right? Here boat takes 90 minutes less to travel downstream. Therefore 90 minutes less means difference between the times T2 minus T1. T2 time for upstream motion is greater, right? T2 minus T1 is 90 minutes. The difference between the timings, right, in upstream and downstream motion is 90 minutes. So T2 is greater here. Therefore T2 minus T1 is 90 minutes. Right? So what is T2? So time is always distance by speed. Here speed is upstream speed and downstream speeds, right? T2 is time with respect to upstream speed. T1 is time with respect to downstream speed, right? So we'll consider T2 as distance divided by upstream speed. Upstream speed minus T1 is same distance will be traveled, right, in downstream motion divided by downstream speed is equal to 90 minutes. So in terms of hour, it is 1 hour 30 minutes, right? So 1.5 hours. Right? Here the distance, what is the distance? Is the distance given? So travel the same distance upstream, right? Here less to travel 36 miles downstream. So distance is 36 miles, right? D is 36 miles, both in upstream motion and downstream motion. Therefore, 36 divided by upstream speed, it is x minus y, right? So speed of the boat minus speed of the stream, right? Minus distance is same 36, whereas downstream speed is sum of the speeds x plus y is equal to 1.5 means 3 by 2, right? Simplify it. So finally we have to find speed of the stream, that is value of y. What is the value of y, right? So here LCM is x minus y into x plus y, which is x square minus y square, right? It is 36. Here value of x is already given. So speed of boat is 10 miles per hour, right? So we'll write. So 36 into x plus y minus 36 into x minus y is equal to 3 by 2. Here 36 and 36x and minus 36x will get cancelled. So we have 36y plus again 36y, right, is equal to 3 by 2 into x square minus y square. X square, x is 10, x square is 100, right? So 10 square is 100 minus y square. Therefore, 72y is equal to, so 3 by 2 into 100 minus 3 by 2 into y square, right? Therefore, 3 by 2y square plus 72y, right, minus 3 by 2 into 100 is 50 into 3, which is 150, is equal to 0, a quadratic equation. So let us convert this coefficient of I square as 1, right? Therefore, so when the whole equation is divided by 3 by 2, right? Equation becomes 3 by 2y square whole divided by 3 by 2 plus 72 by 3 by 2 y minus 150 by 3 by 2 is equal to 0. Right? Very simple calculation. Here 3 by 2, 3 by 2 will get cancelled. So it becomes y square plus, so 3 into 24 is 72, right? So this 2 goes to numerator. It becomes 48y minus, so 3 into 50 is 150, sorry, 150. 50 into 2 becomes 100 is equal to 0. So split the middle term, y square plus 50y minus 2y. It becomes 48y. And product of the coefficient 50 into minus 2 becomes minus 100, which is the last term, is equal to 0. So y into y plus 50 minus 2 into y plus 50 is equal to 0. So we have two values for y. Y is equal to 2 because y minus 2 is 0, right? Y is 2 or y is equal to minus 50. Here y is nothing but speed of the stream, right? Speed of the current or speed of the stream. So which cannot be negative. Therefore, value of y is 2 miles per hour. 2 miles per hour is the right answer. So speed of the stream is 2 miles per hour. Option D is the right answer. So this is an easy question. Only the major part is simplification part, right? We have to simplify this, then solving the quadratic equation, right? Like this, finding the value of y. This is the major part. So remaining parts are easy. So by taking upstream speed and downstream speed, we are finding the value of t, right? Therefore, not t, that is y, value of y, right? So for the given question, 2 miles per hour is the answer. Question number 20. The places P and Q are 27 kilometers away. Two trains with speeds 24 km per hour and 18 km per hour respectively start simultaneously from P and Q and travel in the same direction. They meet at a point R beyond Q. The distance QR is. So we'll consider two places P and Q, right, which are 27 kilometers away, right? Distance between these two places is 27 kilometers. So their respective speeds are 24 kilometer per hour and 18 kilometer per hour respectively, and both, right, both the trains, right, so the having different speeds, so moving in the same direction, right? And they reach the point R and both the trains meet at point R. So we'll consider place R somewhere here, right? Here R is beyond Q, somewhere here. So here we need the distance QR. Let it be D kilometer, right? So let QR be D kilometer, right? Here, time taken by first train to reach R. So one train starts from P, another from Q, right? So time taken by first train to reach R is equal to time taken by second train to reach R, because both the trains meet at place R, right? Therefore, we'll consider time taken by first train to reach R is equal to time taken by second train to reach R, right? Since we can express the time in terms of speed and distance, right? Here speed is equal to distance by time. This concept we all know, right? Therefore, time is distance by speed. So, time taken by first train to reach R is first train covers 27 plus D distance to reach R, right? So, here the distance is, so for your better understanding, I'll consider distance by speed is equal to distance traveled by second train by speed of the second train, right? So distance traveled by the first train is 27 plus D and its speed is 24 kilometer per hour, right? Is equal to distance traveled by the second train is D kilometer and its speed is 18 kilometer. So here students, the question is distance QR. We need the value of D, right? Therefore, we'll simplify it, right? So 27 plus D is equal to D by 18 into 24, right? So 3 into 6, 3 into 8 and 2 into 3, 2 into 4. So 4 by 3 is 27 plus D, right? Therefore, still we can simplify. So 3 into 27 plus D is equal to 4D. So 27 into 3 is 81 plus 3D is equal to 4D. Therefore, 4D minus 3D is D is equal to 81, right? Therefore, so distance between Q to R, QR distance is D kilometer, which is 81 kilometer, is the right answer. Hence, option B is the right answer. Students, if you want to practice such questions on dynamics, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 21. A train covers a distance between station A and station B in 45 minutes. If the speed of the train is reduced by 5 km per hour, then the same distance is covered in 48 minutes. The distance between station A and B is. So students will consider station A and B. Let D kilometer be the distance between them. Right? So here D is distance between two stations. And to cover that distance, a train takes 45 minutes of time, right? With certain speed it is moving. So let S1 be the speed. S1 be the speed of the train in terms of kilometer per hour, right? So in terms of kilometer per hour. So in the second case, if the speed is reduced by 5 km per hour, so we'll consider another case. So here the distance between stations A and B is same, which is D kilometer distance. To cover this distance, a train takes 48 minutes of time because Here the speed is reduced by 5 kilometer. If you consider S2 as a speed of the train in the second case, right? So the difference between first speed and the second speed of the train is 5 kilometer per hour. Speed of the train is reduced by 5 kilometer per hour in the second case. Therefore, S1 minus S2 speed of the train in first case is more, right? Therefore, it takes less time compared to the second case. Therefore, S1 minus S2 is 5 kilometer per hour, right? Difference between the speeds is 5 kilometer per hour. We know that speed can be expressed in terms of distance and time, right? Since speed is distance by time, so here speed of the train in first case is distance d kilometer by time is 45 minutes. We'll express the time in terms of hour, which is 1 by 60 into 1 by 60 or 45 by 60 hour, right? So d in terms of kilometer minus second speed. So speed of the train in the second case is again the same distance d kilometer divided by 48 minutes is 48 by 60 hour is equal to 5 kilometer per hour. What is asked in the question? Distance between two stations A and B. What is the value of D? We need to find the value of D. So simplify it. So here we have 60D by 45 minus 60D by 48 is equal to 5. Right? So here 60D can be taken out. Right? So we have 1 by 45 minus 1 by 48 is equal to 5. Right? So we'll take the product of 45 and 48 as the LCM and the numerator becomes 48 minus 45, right, is equal to 5. Still we can simplify 60D is equal into 48 minus 45 is 3, right? So here we'll take this 45 into 48 to the right hand side part. So it is multiplied by 5. Therefore, D is equal to 45 into 48 into 5 divided by 60 into 3. So only we have the simplification part here. So 5 into 12 is 60, 12 into 4 is 48 and 3 into 15 is 45. So D is 60, right? So we have D as 60. What is D here? So D is distance between two stations, which is 60 kilometer, right? So come back to the question. Distance between station A and B is 60 kilometer. Option A is the right answer. So students, to solve this question, first we need to consider the difference of the speeds, right? In first case, S1 is the speed. In the second case, S2 is the speed, right? In the second case, speed is reduced by 5 kilometer. We have to take that point first. S1 minus S2 as 5 kilometer. So express the speeds in terms of distance and time. Since distance by time is speed, and after simplification, you can get the value of D here. Here, for the given question, 60 kilometer, option A is the right answer. Students, if you want to practice such questions on dynamics, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 22. A man who can swim 48 meter per minute in the still water swims 200 meter against the current and 200 meter along with the current. If the difference between these two times is 10 minutes, so what is the speed of the current? So students will consider a current or a stream like this, right? Man can swim 48 meter per minute in the still water. So if you consider X as speed of that man in still water, right? So X is speed in still water. Speed in still water. Right? So here in still water, he can swim 200 meter against the current. Against the current means in this direction, he can swim 200 meters with the speed, right, which is equal to, that means in still water, he can swim 48 meter per minute. and 200 meter along with the current. That means in the direction of the current, he can swim 200 meters, right? So in both the ways, he can cover a distance of 200 meter and 200 meter, right? And his speed in still water, x is 48 meter per minute, right? So if the difference between these two times is 10 minutes, so let us consider time taken by him in downstream motion. Downstream motion means in the direction of the current, right? So time taken by him is TA minutes, whereas time taken by him in the upstream motion is TB minutes, right? Here TB, so here in upstream, this is upstream motion. So in the opposite direction of the stream, if the person is moving, that motion is called upstream motion, right? Since he is moving in the opposite direction of the current, he takes more time, right? Here TB is greater than TA, right? So TB minus TA difference, time taken by him in upstream and downstream motion, right? Respectively, are TB and TA, and the difference between these two times is 10 minutes. 10 minutes, right? So here we'll consider time in terms of speed and distance covered. Since time is distance by speed, according to the concept of the speed, it is speed is distance by time, hence time is distance by speed. So here time taken, right, in the upstream motion is distance in upstream motion. What is the distance in upstream motion? It is 200 meters, right? 200 meters divided by speed. Here speed is upstream speed, right? So 200 by upstream speed minus time taken in the downstream motion is nothing but distance covered in upstream, sorry, downstream motion divided by downstream speed. Downstream speed is equal to 10 minutes, is equal to 10. What is upstream speed and even downstream speed, right? So here in upstream speed, since the man is moving in the opposite direction of the current, upstream speed becomes x minus y. Whereas in downstream motion, man is moving along with the current in the same direction of the current. Therefore, downstream speed becomes x plus y, right? Here, y is the speed of current, speed of the current, right? Therefore, so in downstream motion, right, along with the speed of man in still water, so the speed of the current also should be calculated, right? Therefore, 200 by in upstream speed. So here we have to subtract the speed of the current, so which is x minus y, minus 200 by downstream speed is x plus y is equal to 10. Simplified. Here value of x is 48 meter per minute, right? So 200 by 48 minus y minus 200 by 48 plus y is equal to 10, right? Therefore, we can take out 200 as common here. So 1 by 48 minus y minus 1 by 48 plus y. Here LCM is 48 minus y into 48 plus y. And the numerators become 48 plus y minus of 48 minus y becomes minus 48 plus y is equal to 10, right? So here 48 and 48 will get cancelled. We have 2y and the denominator becomes 48 square. So a plus b into a minus b. So a square minus b square. Here 48 square minus y square is equal to 10 by 200. So take this 200 to the RHS part, right? So here students, what is 48 square? 48 into 48 is 2304. So numerator is 2y. So 2304 minus y square is equal to, so 10 by 200 is 1 by 20. So here take this 20 to LHS part, it becomes 40y is equal to, so minus y square plus 2304. So after rearranging, so y square plus 40y minus 2304 is equal to 0. So a quadratic equation. How to solve quadratic equation? Quadratic equation, So there are two ways to solve. That means to find the value of phi. One is splitting the middle term. So either you can split the middle term or using the formula. Right? So better to use the formula. Here y is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Here a is coefficient of y square, which is 1. B is coefficient of y, which is 40. And C is the last term, which is minus 48 square. 2304 can also be taken, or 48 square can also be taken, right? So minus 2304 is value of C. Therefore, value of y becomes minus b, which is minus 40 plus or minus root of b square is 40 square, which is 1600, minus 4 times a is 1, 4 times 1 into c is minus 2304, right? Divided by 2 times a is 1, 2 into 1, right? So simplify it, it becomes minus 40 plus or minus root of 1600, 2304. So 2304 into 4 becomes 9216 plus 9216, right? Plus 1600 gives 10816, right? You will get divided by 2. So here students, root of 10,816 is equal to 104. So minus 40 plus or minus, sorry, not root of, it is directly 104 plus or minus 104 divided by 2, right? So value of y can be minus 40 plus 104 by 2, which is equal to, so minus 40 plus 104 means 64 by 2, which is 32. Or there is one more possibility for y, which is minus 40 minus, since it is plus or minus 104, so minus 40 minus 104 by 2, which is minus 144 by 2, which is minus 72, right? So here y is the speed of current, right? So speed cannot be negative. Speed of current cannot be negative. Therefore, value of y is 32. The unit is meter per minute, right? 32 meter per minute is the correct answer. Speed of the current is 32 meter per minute. Option D is the right answer. Question 23. Two trains 108 meter and 112 meter in length are moving towards each other on the parallel lines at a speed of 45 km per hour and 54 km per hour respectively. To cross each other after they meet, it will take. So students will consider two trains, right? So here length of first train is 108 meter and second train is 112 meter. So moving towards each other, right? Moving towards each other like this. So speed of first train is 45 km per hour. Of second is 54 km per hour. So to cross each other after they meet. So students at this point, so both the trains, the two trains are about to meet each other. So at this point, right, if they cross each other, right, so they have to cross each other's length. For example, train A is here. First train of length 108 meter is here. In order to cross the second train, it has to cover 112 meter of length, right? It has to pass the whole length of the second train and also its own length, right? Therefore, total distance here, total distance to be covered by the two trains to cross each other, total distance to cross each other is equal to length of first train, which is 108 meter, plus the second train's length, so 112. So together it is 220 meter, right? Therefore, here total distance is 220 meter. So time taken by both the trains to cross each other completely is equal to, it depends on two factors. One is the total distance. Another factor is, since both the trains are moving in opposite directions, right, we use the term relative speed. Relative speed, when two bodies are moving in opposite direction with two different speed, then the relative speed is equal to sum of their speeds. Sum of their speeds, since two bodies are moving in opposite direction, right? So two trains are moving in opposite direction, therefore their relative speed is sum of their speed. It is 45 kilometer per hour. 45 kilometer per hour means 1000 by, for 1 hour it is 3600 seconds, right? Plus 54 kilometer per hour, 1000 by 3600 meter per second, right? So the relative speed is 45 into, so 5 by 18 plus 54 into 5 by 18 meter per second, right? Meter per second. So here we use time taken by them to cross each other, right? Since time depends on speed and distance, time taken is equal to, since speed is distance by time, time is equal to, what's the value of time? So here the formula says distance by speed. So here distance is total distance to cross each other, which is 220 meter. And the relative speed is how much? This value, right? So we can take 5 by 18 outside. So 45 plus 54. Simplify it, you will get the answer, right? So 220 into 18 by 5 into 100, right? So here 5 into 4 is 25 into 4, 44. So by 100, right? 44 into 18. So 18 into 4. So 18 into 4, again 72 plus 7, 79. 792 by 100. So which is equal to 79, right? So 7.92, sorry, 7.92, which is approximately equal to 8. So since time is expressed in terms of seconds, right, it is approximately equal to 8 seconds, right? So time taken by both the trains to cross each other after they meet is 8 seconds. Option C is the right answer. Question 24. A man can row 3/4 of a kilometer against the stream in 11 and a quarter minutes and return in 7.5 minutes. Find the speed of the man in still water. Very simple question. We'll consider a stream, and man can row 3/4 of kilometer against the stream. Means 3/4 of kilometer means 750 meter. Since the answers are in terms of kilometer per hour, we'll consider 3/4 of kilometer as the distance against the stream. No need to convert kilometer into meter, right? And in 11 and a quarter minutes, so time taken by the man against the stream, that means in upstream motion, right? So to cover 3/4 of a kilometer distance, man takes, so let it be TB or T2, right? T2 is 11 and a quarter minutes. 11 and quarter divided by 60 hour, right? So let it be as it is. And he returns in 7.5 kilometers. So T1 is, that means in a downstream motion, he takes 7.5 minutes to cover the same distance, right? That means in upstream motion also the distance, sorry, in downstream motion also the distance covered is 3.25 kilometer, right? Here we need speed of the man in still water. So we know that downstream speed is speed of man in still water plus speed of the stream, right? So we'll consider X as speed in still water, speed of that man in still water, and Y as speed of the current or speed of stream, right? Here we'll consider downstream speed. Downstream speed means speed when the man is moving along with the stream, right? Therefore, downstream speed is a sum of the speeds of man in still water and speed of the stream. Therefore, downstream speed is x plus y, right? So, according to the concept of speed, x plus y, speed is distance by time. So, in downstream motion, he covers 3/4 of a kilometer in how many minutes? 7.5 minutes, right? 7.5 minutes. In terms of in terms of hour, it is 7.5 minutes divided by 60 or into 1 by 60, right? Whereas upstream speed means, so in upstream motion, man is moving in the opposite direction of the stream, right? In the opposite direction of the stream. Therefore, it is speed of man in still water x minus speed of the stream, right? Because in the opposite direction of the stream man is moving, therefore minus y, minus speed of stream. According to the concept of speed, x minus y is distance covered in upstream motion. Again, it is 3/4, right? Divided by, he takes 11 integer 1/4 minutes, which is divided by 60, means 11 integer 1/4 divided by 60 hour, right? Therefore, here what is asked in the question? Speed of the man in still water. We have to find value of x. For that, we'll consider these two equations as equation 1 and 2. So if you add equation 1 and 2, so you can delete y and minus y, right? Speed of the stream can be deleted so that you can express the equation in terms of x, right? So therefore, equation 1 plus 2 gives 2x in the left hand side part, and the right hand side part becomes, we'll simplify this, right? So 3/4, and the denominator of first equation becomes 7.5, can be written as 15/2 divided by 60, right? Plus second equation 3/4 divided by 11 integer 1/4, that is 45/4 divided by 60, means into 1 by 6 means divided by 60, right? So this 2 into 60 and 4 into 60. So these parts will go to numerator. So we have 3/4 into 15, right? Into 2 into 60 plus 3/4 into 45 into 4 into 60 is equal to 2x, right? Very simple question. 15 into 4 is 60, and 4 and 4 will get cancelled. We have 6 plus here 4 and 4 will get cancelled. 15 into 3, 15 into 4, and 3 and 3 will get cancelled. So we have 4, right? So which is equal to 10. 2x is 10, so value of x is 5. So speed of man in still water is, so 5 km per hour. So in terms of kilometer per hour. Hence option C is the right answer. Question number 25. A train 110-meter long passes a telegraph pole in 3 seconds. For how long will it take to cross a railway platform of length 165 meter? So students will consider a telegraph pole. A train is passing through it. So we'll consider a train of length 110 meter. While passing this telegraph pole, so train has to cover its own length, right? Therefore, distance covered by the train is equal to its own length. So let it be L, right? So which is 110 meter. Here compared to length of the train, length of the pole is very negligible. Therefore, we no need to consider length of the pole, right? While crossing the pole, so length of the pole or this small, if you consider this as length, not the height. So I'm telling about the length, this one, right? So length of the pole is very negligible. Therefore, distance covered by the train while crossing the pole, right? While crossing the pole is 110 meter, and time taken by it is 3 seconds. So first let us find speed of the train. Right, first let us find speed of the train, because while crossing the platform, so we'll consider a platform. Here length of the platform is given 165 meter. So how long will it take to cross the platform? So time taken to cross the platform is asked. So for that we need speed of the train, right? Because speed is distance by time. Distance is nothing but 165 meter. So to cross the platform, so train has to cover 165 meter of distance. Along with that, its own length, right? So 165 plus 110 meter is the distance, right? So time is equal to distance by speed, right? So here we need speed of the train. For that we are taking the first case. So while crossing the pole, so distance is 110 meter, time is 3 seconds. So speed is distance d by time. So 110 by 3. So speed of the train is 3 into 3, 9, 3 into 6. So 36.66 meter per second is the speed of the train, right? Therefore, in the second case, so we have 36.66 meter per second as speed of the train. And the distance covered by the train is, so length of the platform 165 meter plus its own length, right? Length of the train, which is 110 meter. So 165 plus 110 meter, which is d is equal to, so 275 meter is the distance covered by the train. Therefore, time taken to cross the platform, since speed is distance by time, time is distance by speed. Distance is 275. Speed is how much? 36.6 is approximately, it is 37. So you can take it as 37, right? Therefore, simplify it. So you will get 275 by 37. So you have 7 into 8. No, 37 into 7 can be taken. So 7 into 7, 49. Yes, 259. So we have 15 into 9 is 6. 6 minus 5 is 1. So 16 as the remainder. So 7 integer 16 by 37. Right? 7 integer 16 by 7 point something you will get. Right? 16. Look at the options. Here 7.5 second. Right? So 7 point something. Right? So 16 into 2 is 32. You will get 7 point something. So here we'll take the decimal point. So 37 into 4 can be taken, right? So 28. So 148. So 12 is the remainder. So here we can take again 4, not 4, 3, 7.43. So we have, so 111. So 9 is the remainder and it continues. So which is approximately equal to 7.5. Right, 7.5, right? So time taken to cross the platform is 7.5 seconds. Option A is the right answer. Question 26. A train normally reaches its destination in 18 hours while traveling at 63 km per hour. Find the percentage increase in the speed in order to reduce the time by 10 hours. So students, here train reaches its destination in 18 hours, right? So in first case, time taken by the train is 18 hours, right? While traveling d distance, we'll consider distance as d, while traveling distance d kilometer with the speed s1 is equal to 63 kilometer per hour. Right? So in first case, speed of the train is 63 kilometer per hour. So here we need to find percentage increase in the speed. So in order to reduce the time by 10 hours, therefore in the second case, we have to reduce the time taken by the train to reach the same distance by 10 hours. So in the second case, T2, time taken by the train will be 18 minus 10, which is 8 hours. Right? So in order to reduce the time by 10 hours, so the increase in speed should be, what should be the new speed? right? What is the new speed of the train and what is the increase in its speed? Finally, we need to find percentage, right? So here in both the cases, the distance covered by the train is same, right? First, let us find the new speed. That is, in the second case, what should be the speed of the train so that it takes 10 hours less time. That is, it takes only 8 hours of time to reach the distance, right? So once we get the new speed, we have to find increase in the speed and percentage increase in the speed, right? So for that, to find the second speed, right, speed of the train in second case, we need the distance to be covered, right? Therefore, distance to be covered, d is equal to, so based on the concept of speed, distance is speed into time, right? Speed of the train into time, right? We'll consider the first case. So in first case, speed of the train is 63 kilometer per hour and it takes 18 hours of time. Therefore, 63 into 18 gives 1134 kilometer is distance to be covered, right? Now come to the second case, right? To cover the same distance, right? If d is equal to 1134 kilometer and t is time is equal to, so t2 is 8 hours. What is the new speed, right? Speed is equal to, so distance by time, d by t2. So 1134 by 8, right? So divided by 8 is equal to 141.75 kilometer per hour is new speed of the train, right? So 141.75 kilometer per hour. What is the increase in speed? So original speed was S1 63. So new speed is 141.75. So increase in speed. Increase in speed is new speed, which is 141.75 minus 63. So you will get 78.75 kilometer is increase in speed. Here we need percentage increase in speed. So always increase in speed depends on, that means particularly the percentage increase in speed depends on the original speed, right? So here increase in speed, the formula says, so increased speed or increase in speed particularly divided by original speed into 100 gives percentage increase in speed, right? So that means for 63 kilometers original speed, increase in speed is 78.75. Therefore, for 100 original speed, what should be the increase in speed, right? The meaning is this. So you will get 78.75 into 100 divided by 63. So, which is 125 percentage, right? So, increase in speed is 125 percentage. So, percentage increase in speed, option D is the right answer. Question 27. A boat goes 6 km upstream and back to the starting point in 2 hours. If the current of the stream runs at the rate of 4 km per hour, find the speed of the boat in still water. So here students will consider a stream or current, right? And a boat. Here speed of the boat in still water. So we'll take it as x, right? So we'll x as a speed of boat in still water, right? It is given that boat goes 6 km upstream. So if this is the stream direction, right? So here boat goes upstream means in the opposite direction of the stream, right? So 6 km distance covered by the boat is, so upstream motion of the boat is 6 km, right? Back to starting point. So when it reaches its destination, for example, A, and right back to its starting point means again back to B, right? It covers the same distance, which is 6 km, and totally it takes 2 hours of time, right? If you consider T1 as time taken by the boat in downstream motion, whereas T2 be the time taken in upstream motion. Here the total time taken by the boat is 2 hours, right? So we'll consider T1 plus T2 as 2 hours. And if the current of the stream runs at the rate of 4 kilometer per hour, that means speed of current, we'll consider it as y. Let y be speed of current, and its value is already given, so which is equal to 4 kilometer per hour, right? So find speed of boat in still water. For that we need to consider downstream motion and upstream motion. In downstream motion, boat will be moving right along the stream, whereas in upstream motion boat will be moving in the opposite direction of the stream. Therefore downstream speed is always sum of the speeds of boat and the stream. Downstream speed is equal to x plus y, sum of the speed, since boat and streams are moving in the same direction, whereas upstream speed is equal to x minus y, since boat is moving in the opposite direction of the stream. So consider these two concepts, right? So to find speed of boat in still water, which is value of x, right? Therefore x plus y is equal to, according to the concept of speed, it is distance by time. So in downstream speed, boat covers 6 kilometers of distance, right? D by time, let it be t1 we have taken. So x plus y is 6 by t1, right? So here T1 can be written as 6 by x plus y. And also x minus y is same distance covered by the boat in T2, right? In T2 hours, right? Therefore, T2 can be written as, right? T2 can be written as distance is 6 by x minus y, right? To find value of x, we are using the time taken by the boat to cover the total distance. T1 plus T2 is 2 hours. So we'll consider the data given that T1 plus T2 is equal to 2 hours. So we'll consider T1 plus T2 is equal to 2. T1 is 6 by x plus y plus T2 is 6 by x minus y is equal to 2. Simplify it. Here x plus y and x minus y is the LCM. X plus y into x minus y is the LCM. And in the numerator, we can take out 6 and the numerator becomes x minus y plus x plus y, right? Is equal to 2. Here numerator becomes 2x divided denominator becomes x square minus y square is equal to 2 by 6 or 1 by 3, right? Therefore, here 1 by 3, take this 3 to the LHS part, it becomes a 6x. 3 into 2x, 6x is equal to x square minus y square. So y value is already given. Speed of the current is 4 kilometer per hour, right? So substitute that, right? 6x is equal to x square minus 4 square, which is 16. Therefore, x square minus 6x minus 16 is equal to 0, a quadratic equation. So how to solve quadratic equation? So either you can use the formula to find the value of x or split the middle term. So splitting the middle term would be very easy. So x square minus 8x plus 2x. Minus 8x plus 2x is minus 6x, which is the middle term. And the product of minus 8 and 2 is minus 16, which is the last term, right? Which minus 16 is equal to 0. This is how you have to split the middle term in a quadratic equation, right? Therefore, here, take first two terms where x is common. So x minus 8, x into x minus 8 plus 2 into, in the last two terms 2 is common, into x minus 8 is equal to 0. Therefore, x minus 8 is equal to 0 or x plus 2 is equal to 0. Therefore, value of x can be 8 or minus 2. What is x? Speed of the boat in still water. Speed cannot be a negative value. Therefore, x is equal to 8. Right? Therefore, come back to the question. So, find the speed of the boat in still water, 8 km per hour. Option B is the right answer. Question 28. A 100-meter long train running at a speed of 36 meter per second crosses a bridge in 4 seconds. Find the length of the bridge. Very easy question. So here students will consider a train of length 100 meter. Right? Here train is moving at the speed of 36 meter per second. And it crosses the bridge. We'll consider a bridge. Right? So a bridge of length L meter. So the train crosses the bridge in 4 seconds. So here we need length of the bridge. So while crossing the bridge, we'll consider while crossing the bridge. So distance covered by the train will be, so length of the bridge L plus its own length, right? So length of the train. Therefore, distance covered by it is length L plus its own length 100 meter, right? And time is given, time is 4 seconds. And the speed is also given, speed of the train is 36 meter per second. So all the units are in terms of meters and seconds here. So we know that speed is equal to distance by time. So distance d by time. So just substitute the values here. Speed is how much? 36, right? 36 meter per second. Distance is 100 plus L and the time taken is 4 seconds. Here we need to find the length of the train. Length of the bridge, right? Which is L. Therefore, so simplify it. 36 into 4 is 144 is equal to 100 plus L. Therefore, L is 144 minus 10 is 44 meters, right? So which is nothing but length of the bridge, right? Length of bridge is 44 meters. So here option D is the right answer. Question 29. Malla can row along the current at 20 km per hour and against the current at 16 km per hour. Find his rate of speed in the still water. So students, it is very easy question. So along the current means downstream speed is given, right? So here along the current in the same direction of the current. So here downstream speed is given, which is 20 kilometer per hour, right? Whereas upstream speed, so against the current in the opposite direction of the current, upstream speed is given as 16 kilometer per hour. So in the downstream speed, so speed of the man, right? So here x will be taken as a speed of the man, who is Malla, and speed of the current will be taken as y, right? So speed of current will be taken as y. So in case of downstream speed, sum of these two speeds x plus y is equal to 20 kilometer per hour. Since the direction of the man is in the same direction of the current, we have downstream speed along the current in the same direction of the current. So x plus y is 20, whereas upstream speed x minus y in the opposite direction of the current, x minus y is equal to 16. Here find his rate of speed in still water. So speed of Malla in still water is taken as x. So here we need value of x. Right? We'll consider these two as equation 1 and 2. Since we need the value of x, we'll consider equation 1 plus 2 so that you can eliminate y here. Right? So 2x becomes 1 plus 2. Right? In that LHS part becomes 2x is equal to 20 plus 16 is 36. So x is 36 by 2, which is 18, right? Here the unit is in terms of kilometer per hour. So his rate of speed, right? Or speed of Malla in still water. Is 18 kilometer per hour. Option C is the right answer. Question number 13. two trains of equal lengths take 10 seconds and 15 seconds respectively to cross a telegraph post. If the length of each train be 120 meter, in what time will they cross each other traveling in opposite direction? So students, we'll consider a telegraph post like this, and two trains are moving in opposite directions, right? So we'll consider two trains, so of length 120 meter each. So length of the train L is 120 meter. So both the trains having equal lengths, right, of 120 meter. So here first train crosses the telegraph post in 10 seconds, and second train crosses the telegraph post, right? So it crosses the telegraph post in 15 seconds, right? So here lengths are same. So in what time will they cross each other? So in the second case, when these two trains are approaching each other, like, right? So like these two trains are approaching each other, which are moving in opposite directions, right? When they are approaching each other, so in what time will they cross each other traveling in opposite direction? So in what time they will cross each other, right? For that, we need their speeds. When two bodies are moving in opposite direction, so sum of their speed is called relative speed, right? So this whole problem is dependent on relative speed of two bodies, right? So relative speed depends on the respective speeds here. So let us find their speeds, right? So by taking the telegraph post case, right? While crossing the telegraph post, what is their speed, right? So here each train has to cover its own length. Both the trains have to cover their own length while passing the telegraph post, right? Therefore, speed of first train, so we'll consider the respective speeds. So speed S1 is equal to first train. This is with respect to first train. This is with respect to second train. If you consider speed of first train becomes while passing the post. So when it crosses the post, so here length of the post is very small when compared to the length of the train. Therefore, so it becomes the length of the train L divided by time taken by it. Speed of the first train becomes 120 by 10, which is 12 meter per second. Whereas speed S2, speed of second train, it is again distance 120 meter. So when it passes or when it crosses the telegraph post, it covers 120 meter of distance, its own length, right? Divided by time taken by it, which is 8 meter per second. So which is S2, right? Why do we need S1 and S2? So to get the relative speed, right? So in the second case, when they are just about to cross each other, right? So when they cross each other, so here, so in what time they will cross each other traveling in opposite direction, right? So here, while crossing while crossing each other, first train has to cover the distance of or length of the second train. Both the trains having the same length, 120 meter and 120 meter, right? So this first train has to cover the length of the second train and also its own length, right? And also with in the case of second train also, it has to cover its own length, also the length of the second train, right? So the total distance will be, while crossing each other, total distance will be length of the first train plus length of the second train. So which is 120 plus 120, which is 240 meter, right? So what is the time taken to cross each other? For that we need the speed, right? And also we have relative speed. Relative speed means the speed of one body with respect to another, speed of one train with respect to another. Since both the trains are moving in opposite direction, so sum of the speed S1 plus S2 is their relative speed. Since trains are moving in opposite direction, moving in opposite direction. So we'll take sum of their speeds. It is 12 plus 8 meter per second, which is 20 meter per second. Right? Since speed is distance by time, so time is equal to, so total distance. So total distance by relative speed. Right? Relative speed. Total distance is 240 meter and the relative speed is 20. Therefore, it is 12 seconds. Right? So 2 into 12 is 24. Therefore, in 12 seconds, so both the trains cross each other, right? So they take 12 seconds of time to cross each other. Therefore, option C is the right answer, right? So in what time will they cross each other, right? Traveling in opposite direction. So they take 12 seconds of time to cross each other. Option C. Students, if you want to practice such questions on dynamics, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question 31. A train traveling 25 km per hour leaves Mumbai at 10 a.m. and another train traveling 35 km per hour starts at 3 p.m. in the same direction. How many kilometers from Mumbai will they be together? So we'll consider train A, right, traveling with the speed of 25 km per hour, right, leaves Mumbai at 10 a.m. and it reaches some destination D, right, at which it can meet another train, right? So another train starts at 3 p.m., right, from the same point, same station. So the time is different here. So starts at 3 p.m. and another train speed was 35 kilometer per hour, and at some point P, let it be P, so both the trains meet each other, right? So how many kilometers from Mumbai will they be together? That means what is the distance traveled by both the trains so that they can meet each other? Both the trains meet each other at that particular point. We need to find D here. For that, we have to express the speed in terms of time and distance, right? We know speed is equal to distance by time. Distance by time, right? So let us find the distance traveled by the train here, right? Here, first train leaves at 10 a.m., right? After 5 hours, that is at 3 p.m., second train leaves, right? Here, we'll consider case of A and B, train A and B. Here, T1 is time taken by the first train, right? So, time is equal to T1 hours. T1 hours, whereas time taken by second train B, T2 hours, right? Here, T2 hours is nothing but T1 time taken by first train, right? Minus 5 hours. After 5 hours, the second train started from the same station, right? So T1 minus 5 hours. Here time can be expressed in terms of speed and distance, right? So T1 is equal to, so speed of first train, right? Since time is distance by speed, right? Distance covered by the first train is D and first train speed was 25 km per hour. D by 25, whereas T2 is, so same distance by 35. Since T2 is T1 minus 5, we'll substitute that T1 minus 5 is equal to D by 35. We'll consider these as equation 1 and equation 2, right? So we'll divide equation 2 by 1 or 1 by 2, right? So that you can delete the term D here, right? So T1 by T1 minus 5, right, is equal to, or equation 2 by 1 gives T1 by T1 minus 5 is equal to D1 by 25 divided by D by 35, right? So which is equal to 35 by 25. So T1 by T1 minus 5 is equal to, so 5 into 7, 5 into 5. So 7 is to 5. Simplify it. 5 T1 is equal to 7t1 minus 35, right? So 7t1 minus 5t1 is 35. So T1 is 35 by 2, which is 17 and a half. So time taken by first train to reach the destination T1 is 17 and a half hours. So here the question is, how many kilometers from Mumbai will they be together? So we need the value of D. Substitute the value of T1 in equation 1. So we'll solve here. Equation 1 becomes D is equal to 25 T1. So 25 into, so T1 is 17 and a half, right? So 17.5. 17 and a half or 17.5 can also be taken. So here 17.5 into 25 is 437.5, right? So 437.5. So both the trains covered 437.5 or 437 and a half kilometer of distance, so that both the trains meet at point P, right? Therefore, option C is the right answer. Question 32. Man can row 12 km per hour in a still water. He noticed that it takes him double the time to row upstream as compared to downstream. Find the speed of the current. Very easy question. We'll consider a current or a stream, right? Here, so X be speed of the man, right? Speed of the man, which is already given. So 12 km per hour, right? So it takes him double the time. So while upstreaming, right, in case of upstream motion, he takes double the time of downstream motion. So in case of downstream, that is in the same direction of the stream. Downstream motion is in the direction of the stream. If he takes t hours of time, right? So in case of upstream motion, he takes 2t hours of time, right? 2t hours of time. And his speed of the man is 12 kilometer per hour. In case of downstream motion, along with the speed of the man, there also speed of the stream will be considered, right? So let it be y kilometer per hour, right? Let y be the speed of the stream or speed of current, both are same, right? Speed of the current. So here the question is, we need to find speed of the current, right? So both in upstream motion and downstream motion, distance covered will be same. Let D be the distance covered by him, right? D kilometer be the distance covered by him. So here we'll consider D as a distance. Since we have speed of the man and speed of the current, we have to consider downstream speed and upstream speed. Then only we can easily find the speed of the current, because downstream speed and upstream speeds are dependent on speed of the current, right? Whether the body or man or a boat, anything it is, whether the thing is moving in the direction of the current or in the opposite direction of the current, depending upon that we can express downstream speed and upstream speed, right? So we'll consider downstream speed. Downstream speed means in the direction of the stream or in the direction of the current, right? Downstream speed is always sum of the speeds of man and the current in the direction of the current. Therefore, the sum of the speeds, right? So according to the concept, speed is equal to distance by time. If man covers d distance, right? So in downstream motion, and time taken by him is t. So downstream speed becomes d by t, which is always x plus y. Whereas upstream speed is equal to speed of the man minus speed of the current, since man is moving in the opposite direction of the current, right? So opposite direction of the current in upstream motion, therefore minus y, right? Speed of the man minus y. According to the concept, speed is distance by time. In upstream motion also, distance covered will be same, by time is twice the time taken in the downstream speed, right? It is 2t is equal to x minus y. Here value of x is already given, 12 kilometer per hour, right? We'll substitute that value later. So here x plus y is d by t, x minus y is d by 2t, right? Considering these as equation 1 and 2, here we need value of y, right? Therefore, we'll add equation 1 and 2. So we'll subtract equation 2 from 1, right? Right? So 1 minus 2. So that you can delete x, right? Right? Therefore, here, sorry, there is a small change. So you cannot subtract or add. Here, we know the value of x, right? So we don't know the value of d and time taken by that, right? So just equation 1 divided by 2. Equation 1 divided by 2 gives d by t whole divided by d by 2t is equal to x plus y divided by x minus y, right? So here 2 goes to numerator part and d by t will get cancelled. So 2 is equal to x plus y by x minus y. Since value of x, speed of the man is 12 kilometer per hour, we'll substitute that value. So 12 plus x, 12 plus y by 12 minus y is 2, right? Therefore, so 12 into 2, 24 minus 2y is equal to 12 plus y. So we have 24 minus 12 is equal to 3y. Therefore, value of y is 12 by 3, which is 4. So, since y is speed of the current, which is 4 kilometer per hour, right? Speed of the current is 4 kilometer per hour, right? The unit is in terms of kilometer per hour. Hence, option A is the right answer, right? First, we need to know what factor is to be calculated here. Speed of the current, we have taken it as y, right? So here, we have to keep the term y. For that, from equation 1 and 2, only when you divide one equation from another, so you can express the equation in terms of x and y since value of x is already given. And also you can delete the terms d and t which are unknown terms, right? Here unknown terms are d and t. You have to delete that because you cannot substitute their values since it is not given in the question. Therefore you have to delete. For that, the particular operation, mathematical operations to be chosen here. So the suitable operation is division here so that you can easily delete, right? Therefore, for the given question, speed of the current is 4 kilometer per hour is the answer. Option A. Question 33. A train covers a distance of 720 kilometer at a speed of x kilometer per hour. However, if the speed is increased by 30 kilometer per hour, then it will take 2 hours less to cover the same distance. What is the value of x? So, very easy question. Here we have two cases, case 1 and case 2. So, in case 1, train covers a distance of 720 kilometer. Here distance d is 720 kilometer. So to cover this distance, a train is moving with the speed of x kilometer per hour, right? Whereas in the second case, if the speed is increased by 30 kilometer per hour, so in the second case, to cover the same distance, it is given that to cover the same distance, right? Therefore, in the second case also, distance to be covered is the same. Here the speed is increased by 30 kilometer per hour. So it is x plus 30 kilometer per hour, right? So it will take 2 hours less to cover the same distance. That means in first case, if the time taken by the train is, right, t hours. For example, in the second case, time taken by the train will be t minus 2 hours. It will take 2 hours less time to cover the same distance. What is the value of x? Right? So speed of the train in first case, right? So for that, we'll consider the distance, right, in both the cases, which is same, right? So since distance d is equal to speed s into time, distance is speed into time, therefore d is 720 kilometer is equal to, so s is x kilometer meter per hour into time is t hours, right? So here we need value of x, right? So whereas in the second case, distance d is equal to, again, speed into time. So 720 kilometer is equal to, speed is x plus 30 into t minus 2, right? Here we need the value of x. For that, we'll consider t as, so here from case 1, t is equal to 720 by x. We'll substitute the value of t here, right? So by considering these two as equation 1 and 2, right? Substituting t, substituting t is equal to 720 by x, right? Therefore, equation 2 becomes 720 is equal to x plus 30 into t minus 2, which is 720 by x minus 2. Simplify it, x plus 30, right? So here in the next term, we have 720 minus 2x whole divided by x is equal to 720, right? So we'll take this x to the left hand side part. It becomes 720x is equal to x plus 30 into 720 minus 2x. So expand this, it becomes 720x minus 2x square plus 30 into 720. Since 72 into 3, so it is 216, two zeros, 21,600 minus 60x, right? So simplify it. Here 720x will get cancelled. So we have, take this minus 2x square to the LHS part, it becomes plus 2x square plus 60x minus 21600 is equal to 0. So when it is divided by 2, it becomes x square plus 30x minus, so 10800, right? So 10,800 is equal to 0, right? So can we split the middle term here? So can we take 108, factors of 108? So it is 2 into 54, 2 into 27, 3 into 9, and 3 into 3, 3 into 1. Take the product such that their sum, right? Say, take the factor such that their sum should be equal to 30 and the product should be minus 108, right? So here we have 9. No, we cannot consider 9 and other one. 6, right? One of the factors is 6, 3 into 2. Then 18. These two cannot be taken. Then we can't go for, no, you can go for 54, right? You cannot go for that. 36 and 6. 6 and 3. It becomes 39. You cannot go for that, right? So directly you can take the value of x as, so using the formula minus b plus or minus root of b square minus 4ac divided by 2a, right? Here b is equal to coefficient of the middle term, which is 30. A is coefficient of the first term, which is x square's coefficient, which is 1. C is minus 10,800. Therefore, x becomes minus 30 plus or minus b square is 900 minus, minus of minus becomes plus. So 4 times a is 1, right? So it is 4 times 10,800. So it becomes 40,000. So 43,200 divided by 2 times a is 1, it becomes 2, right? Now we have minus 30 plus or minus root of, so 43,200 plus 900, so it becomes 44,100 by 2. So 44,100, its root is, so 210. Since 21 square is 441, so we have, it becomes 210, right? Plus or minus 210 by 2. So we have two values for x, minus 30 plus 210 by 2, or x is equal to minus 30 minus 210 by 2, right? So if it is minus 30 plus 210, it becomes 180 by 2, which is 90. And x is equal to, so minus 240 by 2 is minus 120. 90 or minus 120. What is x here? So here x is nothing but, what is the x? Speed. Speed cannot be negative. It is always positive. Therefore, value of x is 90, right? Kilometer per hour, right? So x is always positive. Positive. So speed cannot be negative. So speed is always positive. Therefore, the correct answer is 90 kilometer per hour. Come back to the options. Option D is the right answer. So bit lengthy process, but you have to decide whether you can split the middle term or use the formula of x, which is minus b plus or minus root of b square minus 4ac by 2a. Right? So this simplification part is bit lengthier. Otherwise, the question is very easy, right? So for the given question, option D is the right answer. Question number 34. Two trains of equal length are running on parallel lines in the same direction at 46 km per hour and 36 km per hour. The faster train passes the slower train in 36 seconds. The length of each train is. So students will consider two trains A and B moving in the same direction with two different speeds, right? 46 km per hour and 36 km per hour, right? Right? So here faster train passes the slower train in 36 seconds. So here, so in 36 seconds, so A passes, here faster train is A, it passes the second train B, right? In 36 seconds. Here we need to find the length of each train. So this question is based on the concept of relative speed. Right? Relative speed is nothing but speed of one train with respect to another train. Right? So here the distance covered by one of the two trains here, right? So here distance covered by train A in a particular time, right? With respect to second train, right? With respect to second train is called relative speed. When two bodies are moving in the same direction, right? Difference in their speeds is considered as relative speed, right? Therefore, relative speed is 46 minus 36, right? In the same direction, if two bodies are moving, then difference in their speed is called relative speed. But according to concept of speed, it is distance covered by time taken, d by t, right? Right? Since we are talking about the relative speed, so we'll consider distance covered by one of the trains, right? Distance covered by first train we'll consider, right? First train divided by time taken to pass the second train, right? So distance covered by the first train to pass a second train divided by time taken by first train to pass second train, right, is equal to 46 minus 36, right? Here we'll consider a train A is somewhere here. It has to pass the second train, right? It has to pass the second train, right? If second train is somewhere here, right? For example, right? So while passing the second train B, A and B are here. While passing the second train B, train A has to cover its length. So for example, if L is length of the train, length of first train, it is given that two trains of equal length, right? So train A's length is L, B's length is also L. While crossing the second train, train A has to cover its own length. Along with its own length, it has to cover length of B also, right? Therefore, distance covered by first train while crossing the second train is its own length, right? Which is L plus length of the second train, right? So L and L are lengths of two trains here, right? By time taken, so time taken to cross the second train is 36 seconds, which is given already, is equal to 46 minus 36 is 10 kilometer per hour. Difference between the speeds is 10 kilometer per hour, right? Therefore, 2L by 36, here time taken by the first train is 36 seconds. Time is in terms of seconds. Let us express speed, which is 10 kilometer per hour, in terms of meter per second. 10 into 1000 meter divided by 1 hour means 3600 seconds. Therefore, 2L is equal to, so we can cancel two zeros and 36 and 36 will get cancelled. So we have 2L as 100. So L is equal to 100 by 2, which is 50. So what is L? Length of each train. So the question is length of each train is L, which is 50 meters. Length is in terms of meter. Therefore, 50 meter is length of each train, right? So come back to the options. Option B is the right answer. Question number 35. A train with stoppages traveled a distance at 60 kilometer an hour and without stoppages 90 kilometer an hour. How many minutes per hour the train stops? So we'll consider without stoppages and with stoppages distances, right? Without stoppages and with stoppages. With stoppages, right? So train with stoppages traveled a distance of 60 kilometer an hour, right? So here speed of train per hour is 60 kilometer, right? So its a speed with the stoppages is 60 kilometer per hour, right? And without stoppages, its a speed is 90 kilometer per hour. With speed is 90 kilometer per hour for every hour, right? So to cover the same distance, train took different speeds, one without stoppage and another with the stoppages, right? Therefore, let the distance be same here. So we'll consider distance covered by the train as d kilometers and here also distance as d kilometers, right? So d kilometer. What is the time taken by the train to cover d distance? Right? Finally, we are going to find, so per hour, how many minutes the train stops, right? For that, we need individual time, right? Individual time taken by train without stoppages and with the stoppages. So time taken by the train, let it be T1 is equal to, according to concept of speed, it is time is distance by speed. So time taken T1 is equal to D by 90, right? So this is without stoppages, right? Therefore, it takes less time. D by 90 is less one, right? With the stoppages, time taken by the train is, let it be T2 is equal to distance by speed, D by 60, right? So which is more? With the stoppages, train takes more time, right? So T2 is greater than T1, right? So this difference in time is the time spent on stoppages, right? Therefore, time spent on stoppages is equal to T2 minus T1, right? So which is equal to T2 is D by 60 minus T1 is D by 90, right? Since LCM is 180, so 60 into 3, hence numerator becomes 3D. And 90 into 2 is 180, numerator becomes 2D. So time spent on stoppages is D by 180, right? So out of the total time, that is greater time T2, which is D by 60, time spent on stoppages is D by 180, right? Therefore, for 1 hour, what is the time spent on, right, stoppages, right? Therefore, time spent per hour, time spent per hour is equal to, so total time or the highest time, right? So that, or in other words, you can consider it as time spent with stoppages, right? So total time spent with stoppages, right? So out of that, so what is the time spent on stoppages? Time spent on stoppages. Therefore, for 1 hour, right? Therefore, out of total time spent with stoppages, which is D by 60, out of D by 60, right? So D by 180 time was spent on stoppages, right? For example, this is the total time. In that, a small time was spent on stoppages. Therefore, in 1 hour, what is the time spent on stoppages, right? Out of 1 hour, that is out of 60 minutes, so what time will be spent on stoppages, or what time will be spent for stoppages, right? So therefore, for 1 hour into 1 hour, right? Therefore, since D by 180, this T1 and T2 are in terms of hours, right? Since D is in terms of kilometer and speed is in terms of kilometer per hour, so T1 and T2 are also in terms of hours, right? Therefore, so time spent on stoppages and time spent with stoppages are in terms of hours. So D and D will get cancelled. We have 60 by 180. This 60 goes to numerator into 1 hour. So which is nothing but 1 by 3 into 1 hour means 1 by 3 hour of an hour, right? 1 by third part of an hour is nothing but 20 minutes, because 20 plus 20 plus 20 becomes 60 minutes, that is 1 hour. 1 by third part of an hour is 20 minutes. Therefore, out of 1 hour in 60 minutes, right? In 60 minutes, so 20 minutes, this time was spent for stoppages, right? Hence, look at the options. Option B is the right answer. Question number 36. A train passes a station platform in 36 seconds and a man standing on the platform in 20 seconds. If the speed of the train is 54 km per hour, what is the length of the platform? So students will consider platform, right? So here, this is a platform of length L, right? And a man standing on the platform. So we'll consider a bit lengthier platform, a man who is standing here. So we'll consider a train, right? So a train of length x kilometer or x meters, particularly x meters. So if the speed of the train is 54 kilometer per hour, speed is given, what is the length of the platform? So here we need the value of L, right? So here we have two cases. So first case is crossing the platform. While crossing it, it takes 36 seconds. And also while crossing a man standing on the platform, train takes 20 seconds of the time. So here we have two cases, crossing platform and crossing a man. Crossing a man. Right? Here while crossing the platform, so train covers the distance covered by the train is length of the platform plus length of the train, L plus X, right? right? Length of the train has to cover its own length. Along with that, it has to cover the platform also. It has to cross the platform. Therefore, distance covered by the train will be L plus X, right? And its speed is given. So speed is 54 kilometer per hour, right? Here we need length of the platform. What is the value of L, right? So to cross the platform, it takes, so how many seconds of time? 36 seconds of time. So first we need the length of the platform here, right? Which is L. So for that we need length of the train also, right? Here we'll consider the second case while crossing a man, right? So train takes how many seconds? 20 seconds of time, right? So, and the distance covered by the train will be its own length, which is x meters or x kilometer or any unit, right? And time taken by it is 20 seconds. So based on these two, right, time and distance, so here we can easily find value of x by taking speed of the train as 54 kilometer per hour, right? So distance becomes since the speed is distance by time, so distance becomes a speed into time, right? Speed into time. So since time is in terms of seconds, speed should be expressed in terms of meter per second. 54 kilometer per hour is nothing but 54 into 5 by 18 meter per second into 20 seconds, right? So this gives the distance 18 into 3 is 54. So 5 into 3, 15 into 20, which is 300 meter is the distance. So which is nothing but value of x, length of the train is, so we'll consider length of the train here. Length of the train, x is equal to 300 meter, right? So here while crossing the platform, so here we need value of L, right? Therefore, speed is equal to distance, which is L plus X divided by time taken, right? Which is time, 36 seconds. Speed is already given 54 kilometer per hour, which is 54 into 5 by 18 meter per second is equal to, so here value of L. So L is nothing but platform length plus X is 300 meters, right? L plus 300 divided by 36 seconds, right? Therefore, so here we need value of L, right? So 18 into 3 is 54. So 15 into 36 gives L plus 300. 15 into 36 is 15 into 6, 90. So 45 plus 9 is, yes, 54 minus 300 gives value of L. Therefore, L is equal to 240 meters. So L is nothing but, so length of the platform, not the train, right? Length of the platform is 240 meters. So option B is the right answer. Students, here to find length of the platform, first we need length of the train, because while crossing the platform, train has to cover its own length. It has to cross its own length. First, let us find length of the train. So by taking the second case, while crossing a man, so distance covered by the train is its own length, which is x. Using the formula of speed, which is distance by time, so we'll consider distance covered by the train while crossing the man, right? Which is nothing but x as a 300 meter. We got it as 300 meter. So here in case of crossing the platform, right, by substituting the value of x here, right? So here speed is equal to L plus x by time, this one. So here x is 300 meters. So after simplification, here we'll get the value of L as 240 meter, right? So which is nothing but length of the platform is 240 meter. Option B is the right answer. Question 37. A man can row at 5 km per hour in still water if the velocity of the current is 1 km per hour. Here is a slight change. Velocity is 1 km per hour and it takes him 1 hour to row to a place and come back. How far is the place? So we'll consider a current or a stream. Right here, man can row at 5 km per hour. So here we'll consider x as speed of man. Speed of man in still water. Still water. Right? Here x will consider a man whose speed in still water is 5 km per hour. And we'll consider y as speed of the current. Right? Speed of the current. Right? So it is given as 1 km per hour. And it takes totally 1 hour to row to a place and come back. If we consider A and B as two places, to go from A to B and to come back to the same position, here the total time taken by him is, so T is equal to 1 hour, right? How far is the place? Right? That means we need the distance AB, right? If man covers D kilometers of distance from A to B, he covers the same distance from B to A also, D kilometer of distance, right? Here we need the value of D. Since we have speed of man in still water and speed of the current, we are going for the concept of which concept? Upstream speed and downstream speed. Right? So here we'll consider two cases. First, we'll consider downstream speed. So downstream motion is nothing but motion of this man in the same direction of the current. So here in first case, he goes in the same direction of the current. While coming back, he goes in the opposite direction of the current, right? So here we'll consider two concepts, downstream motion and upstream motion, and the respective speeds are called downstream speed and upstream speeds. Right? So here downstream speed is nothing but sum of the speeds, speed of man plus speed of the current. Since man is going in the direction of the current, right? We are adding these two speeds. So here downstream speed, so I'll mention it as ds speed, is equal to x plus y. Here what to be calculated? Value of d. Since speed is distance by time, so while going in the direction of the current, man covers d kilometers of distance, right? In 1 hour, right? D by 1 is equal to, here value of x. So speed of man is 5 kilometer per hour plus speed of the current, velocity of the current is 1 kilometer, right? Therefore, here time, so totally it takes 1 hour of time. Here d by 1 is not correct. Distance by time, so let it be t1. It is not 1, right? So to go in the direction of the current, he takes t1 hours of time if you consider. So downstream speed becomes d by t1, right, is equal to 6. So here we'll consider distance by t1 hour is equal to 6. Mention it as equation 1, right? So when he goes in the opposite direction of the current, it is called upstream motion. So in upstream speed, so what is upstream speed? It is speed of the man minus speed of the current, x minus y, right? According to the concept of speed, it is distance by time. So distance is d, by time taken is t2, right? If it is t2 is equal to, so speed of the man is 5 kilometer per hour minus speed of the current, 5 minus 1. Therefore, d by t2 is equal to 4, right? So mention it as equation 2. And here the total time is given, which is 1 hour. So we'll consider individual times, so which is t1 and t2, right? Here d by t1 is 6, so t1 is d by 6, t2 is d by 4. So we'll add T1 and T2. T1 and T2 becomes d by 6 plus d by 4. Since 12 is the LCM, so it becomes 2d plus 3d. So we have 5d by 12. So T1 plus T2 is 1 hour. 1 hour is 5d by 12. So time is distance by speed, which is 12 by 5, right? Here distance d by speed is, it is 2.4, right? So total time is equal to distance by 2.4, right? So it is 1, total time is 1 hour. Therefore d is equal to 2.4 into 1, which is 2.4 kilometer, right? So distance between two places, it is 2.4 kilometer, right? That's what the question is. How far is the place? So the place is 2.4 kilometers, right? From other place, right? The A to B distance D is equal to 2.4 kilometer. Hence option D is the right answer. Question number 38. A boat sails down the river for 10 kilometer and then up the river for 6 kilometer. The speed of the current is 1 kilometer per hour. What should be the minimum speed of the boat in a trip to take a minimum of 4 hours? So here we'll consider the river, right? So boat sails down the river. That means we'll consider downstream motion, right? In case of downstream, so the distance is 10 kilometer, right? Sails down the river. So that boat has got some speed in still water. So we'll consider as speed of boat in still water as x, right? Speed of boat in still water as x, right? So then up the river for 6 kilometers. So here, so in the upstream motion, so this is upstream motion. So up the river for 6 kilometers is upstream motion speed is, upstream motion distance is 6 kilometer. Speed of the current. So here speed of the current will take it as y, right? Speed of the current is given, which is 1 kilometer per hour, right? So y value is given 1 kilometer per hour and we need x value. What should be the minimum speed of the boat in a trip to take the minimum of 4 hours? Here the total time in the trip is given. So t is 4 hours, right? If the minimum time is 4 hours, what should be the minimum speed of the boat? What should be the value of x here? So considering the total time as 4 hours, so considering that value, we have to find the value of x, right? So for that, we'll consider the individual times t1 and t2, right? So let t1 be the time taken in the downstream motion, time t1, and time t2 be the time taken by the boat in the upstream motion, right? So t1, so we'll consider downstream speed and upstream speed here, right? So here, according to the concept of speed, speed is distance by time, time is distance by speed, right? Therefore, distance by the respective speed is downstream speed, downstream speed, right? So here t1 is time with respect to downstream motion. Therefore, the respective speed is downstream speed. T2 is distance divided by upstream speed, upstream speed. Here the total time is given, right? Minimum of 4 hours is given. Therefore, so we'll downstream distance is 10 kilometer. By downstream speed is speed of the boat x plus speed of the stream, right? Therefore, T1 can be written as 10 by x plus speed of the stream is already given 1 kilometer per hour, right? Whereas in upstream motion, right, T2 time taken in the upstream motion is distance is 6 kilometer. Upstream speed is x minus y. Speed of the boat minus speed of the stream. So T2 becomes 6 divided by x minus 1. Right? We'll consider these two as equation 1 and 2. So we have total time, right? Total time taken in the trip, which is T1 plus T2. We'll consider equation 1 plus 2, right? T1 plus T2 becomes 10 by x plus 1 plus 6 by x minus 1. So T1 plus T2 is the total time which is given as 4 hours, right? Therefore, 4 is equal to, so take LCM, right? So in the RHS part, LCM of the denominator is x plus 1 into x minus 1, and the numerators become 10 into x minus 1 plus 6 into x plus 1. So we have only simplification part. So here take this x plus 1 into x minus 1 to the LHS part. It becomes 4 into x square minus 1. So which is in the form of a plus b into a minus b, which is a square minus b square. And here the right hand side part becomes 10x minus 10 plus 6x plus 6. Right? So here it becomes 4x square minus 4 is equal to 10x plus 6x is 16x minus 4. So these minus 4 and minus 4 will get cancelled. We have 4x square minus 16x as 0. So you can take out 4x common. So it becomes x minus 4 is equal to 0. So we have two possibilities for x. 4x is equal to 0 or x minus 4 is equal to 0. If 4x is 0, x becomes 0, right? Or x is equal to 4. What is x according to our assumption? Speed of the boat. Speed of the boat in still water. It cannot be 0, right? So speed of the boat is equal to 4 kilometer per hour. Is the unit in terms of kilometer per hour? Yes. So minimum speed of the boat in a trip should be 4 kilometer per hour, so that it takes minimum time of 4 hours, right? So option D is the right answer. Question number 39. In an hour, a boat goes 17 kilometer along the stream and 9 kilometer against the stream. Find the rate of the current. So we'll consider a stream, right? Boat goes 17 kilometer along the stream. That means in downstream motion, right? Here boat goes 17 kilometer per hour. In an hour means per hour, right? Therefore, its downstream speed becomes x plus y is directly given 17 kilometer per hour, right? It is sum of the speeds of boat and the stream or the current, which is given, right? 17 kilometer distance per hour is directly given, right? Therefore, downstream speed is 17 kilometer per hour and it goes 9 kilometers against the stream. That means upstream speed is directly given, right? For every hour, so it goes 9 kilometer. That means x minus y. So speed of the boat minus speed of the stream or current is directly given as 9 kilometer per hour, right? Therefore, x minus y is equal to 9 kilometer per hour, right? So here we need the rate of the current. So or the speed of the current. Rate means for every unit time, what is the distance covered by the current? That is nothing but rate, right? So in unit time. So distance in unit time is called the rate, right? Therefore, rate of the current, which is y, we need to find the value of y, right? Here, x is speed of the boat, y is speed of the stream or speed of the current. So for that, we'll consider these two equations as 1 and 2. We'll just subtract equation 2 from 1. or 1 from 2, so that you can delete x, speed of the boat, right? So x and x will get cancelled. We have 2y as 17 minus 9. So 2y is equal to 8. So value of y is equal to 4 kilometer per hour, which is nothing but rate of the current. Rate of the current or speed of the current. That means current goes 4 kilometers. It goes 4 kilometers in every hour, right? Therefore, 4 kilometer per hour is the answer, option C. Question number 14. A man takes twice as long to row a distance against the stream as to row the same distance in favor of the stream. What is the ratio of the speed of the boat in still water and the stream? So very easy question, students. So here we'll consider a stream, right? And a boat. So boat and a stream. Here we'll consider x as speed of the boat. Speed of the boat, and y as speed of the stream, right? Speed of the stream. So what is asked here? So the ratio of speed of the boat to stream. So here we need x is to y ratio, right? It is given that man takes twice time, right, in the opposite direction of the stream. So while rowing in the opposite direction of the stream means in upstream motion, right? So while going upstream motion, he takes the time twice as long to row the distance against the stream as to row the same distance in favor of the stream. So if the man takes t hours of time, for example, time is t units, t hours or t minutes or t seconds in the downstream motion, right? If it is downstream motion, right, man takes t units of time in the downstream motion, he takes 2 t units of time in the upstream motion. That's what the meaning of the sentence. Man takes twice as long to row a distance against the stream. Against the stream, he takes 2 t units of time. As to row the same distance in favor of the stream, he takes t units, right? So here we need x is to y ratio, right? And he covers the distance d. Here, he covers the distance d in both the motion, downstream and upstream motion. So here we'll consider d as distance, distance between places, between places, right? Here we need x is to y ratio, right? For that, we'll consider downstream speed and upstream speed separately, downstream speed and upstream speed, right? Upstream speed. So here downstream speed is nothing but x plus y, sum of the speeds of boat and stream. According to the concept, it is distance traveled by time taken. In downstream motion, boat takes t units of time. So it becomes d by t. Whereas in upstream speed, it is nothing but x minus y, speed of the boat minus speed of the stream. Since boat is moving in the opposite direction, right? Therefore, minus y, minus speed of the stream gives, right? According to the concept, distance is the same. Distance by time is twice the time taken in the downstream speed, which is 2t, right? So here we need the ratio of speed of the boat to speed of the stream, which is x is to y. So you cannot delete the terms x and y here. So here only possible operation is the division method. So by considering these two as equation 1 and 2, so here we'll divide one equation by another one. 1 divided by 2 gives, right? X plus y divided by x minus y is equal to d by t divided by d by 2t, right? Therefore, x plus y by x minus y gives, here d by t and d by t will get cancelled. This 2 will go to the numerator, right? It becomes 3 by 1, right? Therefore, x plus y becomes So 3x minus 3y, right? Therefore, 3 by y, 1 minute. So here x plus y by x minus y, yes, d by t, yes, this 2 will go to numerator. Yes, it becomes 2 by 1, not 3 by 1, 2 by 1. So it becomes 2x minus 2y, right? So we have y plus 2y is equal to 2x minus x. So 3y is equal to x. Therefore, x by y, here we need x by y ratio is 3 by 1. So here x is nothing but speed of boat speed, right? Speed is to speed of the stream or current. The ratio is 3 is to 1, right? Hence, look at the options. Option C is the right answer, right? The ratio of the speed of the boat in still water and the stream is 3 is to 1. Hence, option C is the right answer. Students, with this, I am completing this paper. If you want to practice many more questions on dynamics, like questions on trains, boats, and streams, like upstream speed and downstream speed. So, to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you all the very best for your future exams.